Good morning, ladies and gentlemen. Welcome to the CHK MIT Joint Workshop on E-Learning and Big Data. I'm Gloria Chen, the MC of today's event. We are pleased to have with us the following officiating guests: Professor Joseph Sum, Vice Chancellor and President of CHK. Mr. Patrick Green, Vice Chairman of the Board of Trustees and Chairman of the Board of Directors. Professor Benjamin Wang, Provost of CHK. Mr. Ian Yu, Trustee and Project Representative, Dr. Stanley Ho, Medical Development Foundation. We are also delighted to have 4 distinguished speakers from MIT and CHK to address the workshop today. We invite Professor Benjamin Wang, Provost of the Chinese University of Hong Kong, to give us an opening address. Professor Wang, please.
Distinguished professors from the Massachusetts Institute of Technology, Vice Chancellor, Mr. Patrick Yun, distinguished guests and colleagues. It gives me great pleasure to be able to invite 4 distinguished speakers from MIT who are movers and shakers in our field to present at the CUHK MIT Joint Workshop on E-Learning and Big Data. To all of you, let me extend my warmest welcome to the Chinese University of Hong Kong. The idea of organizing this workshop emerged from a visit by the CUHK delegation to MIT and edX in last June. After the visit, CUHK invited MIT to gather a team of faculty members to visit with us to discuss the future of education as afforded by new technologies in e-learning, which generates big data that allow us to understand learners' behavior. To this end, I wish to thank our distinguished speakers from the MIT Computer Science and Artificial Intelligence Laboratory for generously sharing their rich experience and insights with us. They are Professor Victor Su, Delta Electronics Professor of Electrical Engineering and Computer Science, Professor Steve Ward, Professor of Computer Science and Engineering, Professor Chris Turman, Director of Academics, Ethics, and Professor Bob Miller, Associate Professor of Computer Science and Engineering, Electrical Engineering and Computer Science Department. From their talks, we'll hear about how algorithmic thinking should be injected into our education, how new pedagogies can enhance learning at scale on the MOOC, our massively online open courses platform, how learning at scale generates big data that for our observation at scale to understand learners' behavior that would benefit either small group teaching, as well as how to develop automatic content processing and search technologies to facilitate learning. In addition, our program also includes an interdisciplinary lineup of speakers from CUHK to augment this workshop's coverage on education with perspectives from different disciplines. You will hear about the latest developments in CUHK's new Big Data Research Initiative, our educators' unique perspectives on technology-mediated learning, on social scientists' view on how e-learning can facilitate education across disciplines and across cultures, and how big education to realize scale education at any time, anywhere, on any device. Most importantly, I'd like to thank Mr. Patrick Yun, CUHK Honorary Fellow and Vice Chairman of the Sir Stanley Ho Medical Development Foundation, as well as his colleagues, Mr. Ian Yun and Mr. K.T. Kun, for offering us the strongest support in co-organizing this workshop. Ladies and gentlemen, on behalf of the university, may I welcome you again to this workshop. I'm certain that this time we would spend here will be very productive and the fruits it bears will benefit the development of e-learning with the use of big data for our future education. Thank you very much.
Thank you, Professor Wang. Today's workshop is co-organized with the Dr. Stanley Ho Medical Development Foundation. May we invite Mr. Ian Green, trustee and corporate representative of the foundation, to give a welcome address.
Hello, professors. I can use this. They say the mark of a good presentation is always never talk right after someone with more credentials than yours. But unfortunately, I've been put to speak by Professor Wang. And so, my name is Ian. I'm from the trustee of the Dr. Stanley Medical Development Foundation. And so, we are the proud sponsors of this workshop. And so, when Professor Lane told us that they want to do this joint workshop at CUHK with MIT, we said, yes, definitely, because the mission of the foundation really is the betterment of the human condition through medical research and education. And so this e-learning is very consistent with our mission. And I actually, in order to illustrate how this is so serendipitously consistent, I wrote a piece, mainly because as a foundation, we have nothing as high-tech with MIT, so we have to go very low-tech. So this is, before ball pen, this is just brush. And this is by the educator, Zhang Zhang, a Northern Song educator, and he said, I'm going to use Cantonese because you travel for so long, you're supposed to be subjected to Cantonese Mandarin after such a long flight. When he did not, so putting the soul into heaven and earth, when someone giving a purpose to the living, when you walk in the computer doesn't like my calligraphy. To continue the lost teachings, or the teachings of the past ages, to create, to beget 10,000 generations of peace and prosperity. And we believe that the only way to accomplish this, of Mr. Zhang, Master Zhang, 1,000 years ago, is through learning, education. Because just to quote one more person, John Dewey. John Dewey was the Columbia professor, who was the professor of Hushi, the Chinese philosopher. And what's interesting about him is, because we are in the spirit of the US and China cooperation today, Professor Dewey actually gave the series of lectures in 1919 in Peking University that sparked off the intellectual revolution. And he said, education is not the preparation for life. Education is life itself. And so in order to put Masters Zhang and Dewey together to create this, education is of vital importance. But you look at both of what they're saying, it's not just education, it's education on a mass scale. And in order to do that, you have to put the E before the learning. And that's why we're very, very excited about this workshop. And just to call one more person, Mark Twain. The secret of getting ahead is getting started. So let's begin.
Thank you, Mr. Green. To commemorate this special moment, may I invite the following guests for a group photo: Mr. Patrick Green, Mr. Ian Green, Mr. K.T. Boone, Director of Operations, Dr. Stanley Ho Medical Development Foundation, Mr. Joseph Zhang, Professor Joseph Zhang, Professor Benjamin Wang, Professor Victor Xu, Delta Electronics Professor of Electrical Engineering and Computer Science, MIT, Professor Steve Ward, Professor of Computer Science and Engineering, MIT, Professor Chris Charman, Director of Academics, MIT Ethics, Professor Rob Miller, Full Professor of MIT, Professor Hao Tai, Pro Vice Chancellor of CUHK, Professor Alvin Learn, Dean of Faculty of Education, CUHK, and Professor Helen Mann, Director, Stanley Ho Big Data Analytics Research Center, CUHK. Professor Chi Yun Chiu, Dean of Faculty of Social Science, CUHK. I will now begin our first session of today's workshop. May we invite Professor Helen Mang, Director of the Stanley Ho Big Data Decision Analytics Research Center, to give the first talk. Professor Mang is Professor and Chairman of the Department of System Engineering and Engineering Management, the Chinese University of Hong Kong. She received all her degrees from MIT. She is the former Associate Dean of Research in the CUHK Faculty of Engineering. She is also the founding director of the Microsoft CUHK Joint Laboratory for Human-Centric Computing and Interface Technologies, which has been recognized as a Ministry of Education field laboratory since 2008. In 2013, she helped establish the CUHK Stanley Ho Big Data Decision Analytics Research Center and served as its founding director. Professor Mang's local and international professional services include convener of the Working Party for the 2015 Manpower Survey of the Information Technology sector in Hong Kong, and convener of the Engineering Assessment Panel of the Hong Kong SAR Government Research Grants Council's competitive funding scheme for the self-financing degree sector. She is an appointed member of the Hong Kong Government Steering Committee on e-health record sharing, the Hong Kong Productivity Council, and the former member of the government's Digital 21 Strategy Advisory Committee and Research Grants Council. She served as the editor-in-chief of the IEEE Transactions on Audio, Speech, and Language Processing and was elected into IEEE Board of Governors in 2014. Professor Mang received the 2009 Ministry of Education Higher Education Outstanding Scientific Research Output Award in Technological Advancements and CUHK's Faculty of Engineering Exemplary Teaching Award, Young Researcher Award, as well as Service Award in previous years. She's a Fellow of the Hong Kong Computer Society, Hong Kong Institution of Engineers, and was elected IEEE Fellow for her contributions in spoken language and multimodal system. The title of her talk is Big Data Decision Analytics at CUHK. Professor Mang, please.
President Song, distinguished professors from MIT, dear colleagues, students, ladies and gentlemen, good morning. It gives me great pleasure to give you a presentation of our new center. It's a little under 2 years old, Stanley Ho Big Data Decision Analytics. So big data is all the hype. You hear about it every day. The question is, what is big data? In fact, big data is characterized by several V's. They are shown here. So, first of all, big data has high volume, data at scale. We have massive amounts of data, and we need to handle large-scale terabytes to petabytes of data, depending on the domain of application. Big data is data with velocity. It comes at accelerating speeds in terms of its creation, processing, and its need to be analyzed. And sometimes we have to analyze streaming data to enable instantaneous decisions. Big data also comes in many forms. There's structured data, semi-structured data, unstructured data, text, images, audio, video, multimedia, and many different multiple modalities. Also, the V for veracity, data uncertainty. Big data veracity refers to the level of reliability that is associated with certain types of data. And we need to manage the reliability and predictability of inherently imprecise data types. And finally, perhaps most importantly, we need to derive value, V for value, from big data, optimize decisions. We need to extract intelligence from massive data and improve our decision-making and performance to gain competitive advantage. So this infographic actually gives you an idea of big data coming every minute of the day. So you can see, for example, we have 72 hours of new video going on YouTube. We have WhatsApp is very popular in Hong Kong. We have over 300,000 photos that's shared. Amazon makes 83,000 online sales and so on. So it comes in all the V's. Now, for CUHK, in fact, it is the vision of our leadership to embark on data-intensive research. So with strong support from the Dr. Stanley Ho Medical Development Foundation, Mr. Patrick Hoon and his colleagues, we're able to establish the Stanley Ho Big Data Decision Analytics Research Center a little under 2 years ago. And basically, this center is coordinated by the Faculty of Engineering, so we take a focus on information processing, covering the entire food chain from data capture to processing, modeling, analysis, understanding, manipulating, and visualizing data. And we research in algorithms, computation, and analytics. In terms of the domain, we actually cover 6 major domains: health, environment, learning, logistics, social, and finance. And in the next few slides, I will give you an example of several of the domains covering our work. But actually, we have a lot more projects, so you will get a flavor of what we're doing in the center. Starting with health. So this is work done by my colleague, Professor Calvin Choi, on prescriptions based on patient records. In fact, he had a study where he was comparing 2 hypertensive treatments that are commonly used in the hospital authority system in Hong Kong, perindopril and lisinopril. The data source comes from Hospital Authority, which has a comprehensive computerized patient recording system since 2000 and has some 7 million patient records with clinical and demographic parameters and drug prescription details. In his study, he extracted patients that are prescribed with these 2 treatments in all the public hospital records from 2001 to 2005 and followed through these records till 2010. And it is found that long-term use of lisinopril has significantly higher cardiovascular mortality than perindopril. So big data actually informs us in terms of side effects or risk, efficacy of drugs. My second example relates to the domain of environment. In fact, we are concerned with air pollution and health. In the WHO report in 2014, it was stated that the single greatest environmental health risk on Earth was air pollution, because 1 in 8 of the total global deaths in 2012 was due to air pollution, amounting to 7 million people dying due to exposure to the pollutants, of which more than half of the deaths were caused by indoor pollutants, especially indoor cooking stove fuels like wood and coal. So we actually have a group, a very interdisciplinary group, looking into air pollutants. We want to understand the spatial and temporal patterns of air pollutants in Hong Kong through satellite images, visibility levels obtained through pictures and photos. We also look at the ground stations for air quality monitoring, and also we use portable sensors to get the air pollution levels in between ground stations. So we have images and direct measurements, we have fixed equipment and mobile equipment. And the concern is that we want to know and understand our exposure to the pollutants, and in fact, our population becomes susceptible to various diseases that are attributed to these exposures. So we want to understand the environmental exposure matrix on different pollutants at the personal level. This is our grand goal. And in fact, we are mindful of the Hong Kong environment, where we have a lot of traffic at the street level. We also need to look at the high rises and the vertical distribution of air pollutants. So we actually have a quadcopter that flies up and down the engineering building. At each level, it will station itself, and a portable sensor is mounted on this quadcopter. We also measure outdoor and indoor levels, and so hopefully we don't have to wear these masks indoors. But anyway, so this is a very labor-intensive process. But what we want to do is we want to collect all this data, indoor and outdoor data, vertical spatial distributions, and we want to combine with perhaps meteorological data and understand their effects in relation to other environmental conditions and also various indicators of public health. So this is actually a very interdisciplinary group that is undertaking this project, from engineering, from geography and resource management, and also from public health. And in fact, our Big Data Center is collaborating with another institute in CUHK, the Institute of Future Cities, which is directed by Professor Leung Yi. The third domain that I'd like to provide you with an example is in the domain of logistics. In fact, logistics is one of the pillar industries of Hong Kong. And we also cover various transportation logistics, commercial business-related logistics processes in our center. But in particular, there's this new area of humanitarian logistics that is of interest to our group. Humanitarian logistics investigates systems and methods in logistics and supply chain operations for disaster relief. So actually here you see the photos of Kasanuma in Japan, one day after the tsunami, and the bottom one is 2 years after the tsunami. In fact, when people think about disaster relief, most of the time they think of emergency response, recovery in the short term, post-disaster, and redevelopment in the long term, also post-disaster. However, our colleagues advocate the importance of readiness. So we have 4 R's here, readiness. And readiness refers to being aware of the precautions that are needed and being able to be prepared. So in fact, more preparedness will lead to better response. So there's a recent paper published by my colleagues, Professor Jenny Leung and Professor Yong Hong Kuo, on disaster preparedness planning. In fact, they have developed a tri-level mathematical programming model where they look at the pre-disaster case and they plan evacuation center locations and inventory prepositioning of emergency supplies. They also simulate various scenarios during the disaster, analyze them, prepare for the worst case in each scenario, and the worst case being that perhaps even the evacuation centers that have been planned may be damaged. And they also devise post-disaster measures. So given a damaged scenario, their model determines the distribution network of the delivery of emergency supplies, the quantities of delivery to minimize recovery costs. And moving forward, they want to use big data. They want to enhance their model with multimodal data from sensing and monitoring different conditions, use of historical data for simulation, and also analysis of social media data. And the fourth domain is on learning. In fact, being a student of Professor Victor Zhu, my work largely centers upon speech and language processing. And one of my projects is on online pronunciation training. So language learning is fun. And if you want to speak a language well, you need to train a lot, practice your pronunciation a lot. And in our work, our target audience is for Chinese learners of English. And the motivation was actually, at the time, our vice president asked me, his wish is to improve the general English proficiency of CUHK students. So he says, well, Helen, you have a lot of tools in your lab. Can you put something together? Now, it turns out to be a very interesting research problem. So we actually conducted R&D in mispronunciation detection and diagnosis. And the motivation, of course, the grander motivation is that there are over 2 billion English learners worldwide. And the proportion in Asia alone exceeds the number of native speakers. So we need pronunciation training platforms that are online. And the new technologies can provide new learning platforms that are personalized, self-directed, private, round-the-clock, and providing perceptual and productive learning, and also offering immediate diagnostic feedback. So this is a very interesting area where we see the confluence of linguistics, speech science, pedagogy, and big data research. Because in fact, the approach that we take, which is using deep neural networks, for deep neural networks, you need to train it with a lot of speech data. The more data, the better. So I will show you a very short demo. Guess it doesn't come out. It's okay. I'll show you the demo later. let me continue. So that was a very brief introduction of our work in big data in the Big Data Research Center. And that leads me to the background of today's workshop. In fact, we are all aware that MIT is very well recognized worldwide in its longstanding efforts in transforming education. It has many pioneering efforts in advancing knowledge to allow students to learn more and learn better. And MIT continues to reinvent the classroom and increase accessibility to education. In fact, CSAIL, the Computer Science and Artificial Intelligence Lab, where all of our 4 distinguished professors from MIT came from, they have a dedicated effort in understanding learning through big data analytics. I can also give you 2 examples of efforts in MIT to transform education, starting with the MIT OpenCourseWare, which was launched in 1999, where MIT was using the internet to openly share education resources. And by 2014, they have over 2,000 courses published, 1 billion page views, and 170 million visits. More recently, there is the launch of edX, which is a MOOC, massive online open course online learning platform. And edX is a nonprofit initiative founded by MIT and Harvard in 2012. And it hosts hundreds of courses with millions of student enrollments. So you may look at this very special logo, and this looks like a very interesting logo. And in fact, the real building looks like this, right? So with the kind coordination of Professor Victor Zhu, our president actually led a delegation with our provost and Mr. Patrick Kuhn to visit CSAIL in Boston and also edX last June. And we also met with MIT President Professor Raphael Reif, and also MIT's Vice President, Professor Claude Canizares, and also MIT Chancellor of Academic Advancement, Professor Eric Grimson. So there was a lot of discussion on e-learning and big data, and we thank the MIT professors for sharing with us very generously their rich experiences and insights. Now, that leads us to today's workshop, because the visit led us to realize that, in fact, it is very important and timely for CUHK to consider the in-residence teaching vis-a-vis online teaching. In fact, the emergence of e-learning technologies is enabling the education sector to translate in-residence teaching, for which we have a lot of experience, towards online teaching, which is generally a novel, new modality of teaching. But online teaching is very attractive because it offers accessibility to a huge population of students on a very interactive and highly social environment. So moving towards the democratization of education. And such an environment also allows us to capture very valuable big data traces of learning activities that allows us to understand learning processes and learning outcomes. And this kind of learning analytics can inform pedagogical actions, which can improve education both online and in the classroom. So how to establish this feedback loop to achieve symbiosis between classroom learning and e-learning is a very exciting direction for us to pursue for the betterment of education. And this direction is of great interest, not only to the big data researchers, which for now in CUHK is mostly engineers and scientists, but also to our experts in education, social science, and other disciplines. So it is a very interdisciplinary endeavor. So actually with this, I hope I can set the stage for a fantastic lineup of invited talks that are coming up in this workshop. So I guess for now, I will briefly take a break and show you the demo, which somehow I had some technical difficulties. So let me try again. Okay, here. So this is my pronunciation training system, and the student can freely input any text into the system and look at the International Phonetic Alphabet for every word that should be pronounced, that they wish to practice, and they can
These
play.
ships take cars across the river.
So it will generate a visualization on the fly. This is the articulation animation based on text-to-audio-visual speech synthesis. And it is generated in exaggerated modes so to enable better visualization for learning. And so that's perceptual training. But we also want to support productive training where the student can try out and record himself.
These ships take cars across the river.
And with mispronunciation detection technologies, we are able to detect words that the system didn't like so well and show them in red, and the student can click on the model pronunciation
River.
and compare with his own pronunciation.
River.
And also look how this articulation should be done. Okay, so currently it's at this stage, and we actually received a teaching development grant. So this system is actually accessible from all the language labs across the campus, and we hope that it will contribute a little bit to what's online pronunciation training. So that concludes my talk. Thank you very much.
Thank you, Professor Mann. The next talk will be presented by Professor Steve Ward, Professor of Computer Science and Engineering in MIT Computer Science and Artificial Intelligence Laboratory. Professor Ward is the Professor of Computer Science and Engineering at MIT, whose faculty he joined in 1974. Since that time, his teaching and research have dealt broadly with the architecture of computer systems at both hardware and software levels. Recent research foci have included goal-oriented computing and related variants of conventional computing models. Currently, his primary interest is in education, including the engineering of educational tools, experiences, and concepts. Professor Ward holds SB, SM, and PhD degrees from MIT. The title of his talk is Algorithmic Education. Professor Ward, please.
Well, thank you. Your four visitors today from MIT are all computer scientists, and we're all excited about the interaction between computer science and education. In the deployment arena, we're all excited about e-learning and MOOCs and all of that stuff. And I share that excitement, and we're all involved in various aspects of that. I was encouraged, on the other hand, by Professor Zhu to talk about something that's slightly different, although I think closely related, which is also an interaction between computer science and education, and one that has, in my view, an equally strong impact. It has to do with computer science changing not only the way that we teach, but in a sense, what we teach. So let me begin by talking about our traditional approach to education. Okay? Traditionally, we take kids and we first educate them in sort of a set of core basic skills, reading and writing and math and literature and history and so on. And there's this set of things that we teach our kids all more or less at once. We teach them all at once because they kind of reinforce each other. We use their language skills to talk about problems in science. We use math to deal with science problems and so on. So each of these basic skills plays an essential role in the education of the other basic skills. And once we've done that, in later phases of their education, we go on and selectively to teach them about specialties. We might teach them to be accountants or engineers or computer scientists. So that's kind of the tradition that we've all grown up with and have all kind of believed in. But there is a growing movement that argues that that set of core basic skills should contain at least a piece of computer science. That basically, this idea of that I've been calling algorithmic thinking, the notion of an algorithm as a way of specifying behavior, is a conceptual revolution that is exceedingly important, and that should be incorporated into these basic into the basic core educational framework. So that's the idea that I want to explore, and I'm of course not the only one that is exploring it. What I want to do first is kind of just to be perfectly clear, the things I'm not talking about. I'm going to name a few things that I'm actually not talking about here. Although all of these things I think are good and I'm enthusiastic about them, but these aren't the topics that I'm focusing on. Okay, the first is sort of the MOOC scene, massive online education. I think that's a wonderful thing. I think it's actually revolutionizing education. It's going to, over the next 50 years, change universities. But that's not what I'm talking about. Okay? There's also vastly increasing use of computerized tools, simulation models and things like that in education. I'm not really talking about that either, although that is related. And finally, there is a strong movement to push programming skills, okay? The idea that we should make all of our citizens, all of our students should be expert in programming. I think that's a great idea. I think programming is a basic and very useful skill, but that's not exactly what I'm talking about either, okay? What I'm really talking about is a conceptual revolution that I think it underpins a certain approach to education. So let's look quickly at our sort of existing models of understanding. We measure our students' understanding in a variety of ways. We feel that a student has some level of understanding if they can describe what it is they understand. Okay? Maybe a slightly higher level of understanding is that they can give up coherent explanation of it. They can give a little talk on it to somebody else who's naive about it. Okay? A third level is that they can answer questions about it. Now this is the kind of thing that we use to measure the students' mastery of a topic. We give them quizzes where we ask questions and expect them to get the right answers in order to demonstrate their understanding. There's a fourth level, which is slightly more sophisticated, and that is if I really understand something, for example, I understand how some law of physics works, I can use it to predict behavior of real-world systems. So the ability to predict behavior is another model of understanding and a way of measuring a level of understanding. Now, all of these are commonly used in traditional education, and they all fit within this sphere of the traditional core. If you have language and math skills, and depending on the topic, science and history or whatever, you can demonstrate all of these modes of understanding. There is another mode of understanding, which actually has been popular for hundreds of years in universities, and is getting a new push from the online education community, and that is teaching as a way of demonstrating understanding. It's closely related to the earlier ones, but it's more and more defended as a piece of the educational experience, to demonstrate that you understand something by doing some teaching of that something. Okay? But finally, there is the new model that is enabled by this algorithmic insight. Okay? If you really understand something, you can program it. Okay? if there is a behavior that results from some interaction that you really understand, you can write a program that emulates that behavior by that kind of interaction. Okay, well, many people refer to what I'm proposing here as computational thinking, and the idea is, of course, not new. We can look at some fairly early traces of it, some of which trace back to Professor Seymour Papert at MIT, who's famous for a lot of things, many of them education-related. He came up with a constructionist model of learning and invented a language, a programming language called Logo, which was designed to teach computation ideas to kids. And he actually coined the phrase computational thinking some decades ago and has mentioned it in lots of his works. He was very interested in sort of infusing the general education mechanism with these computational ideas. And there were others that had that same kind of early instinct. But it was in the year 2006 that Jeanette Wing, who many of us at MIT remember fondly from her graduate student days there, Jeanette Wing published a short, couple-of-page piece in the Communications of the ACM, making the argument that these computation ideas, these ideas that are at the fundamental level of computer science, are not just for computer scientists, they're for everybody, and that we should infuse them in everybody's education. Well, this was an interesting piece, and I highly recommend that any of you who aren't familiar with it go back and read it. It immediately resonated with a large number of people, many of them computer scientists, but a number of other people involved in education, and it basically caused an explosion of activity and reaction. So, immediately after Jeanette Wing's publication, there were books written about computation thinking, there was lots of papers published, there were centers opened in universities researching the idea of computational thinking, infusing that in various educational projects, and so on. They're just one thing after another, and that explosion is still going on. There are people who are betting their careers on this idea of computational thinking. It made a huge, huge splash in the community. So, we are all familiar with the impact of computational thinking on various other non-computer science topics, okay? Everybody has their own list. Just to mention a couple of them, there's economics, okay? There are companies like Rolesia, I mentioned up there, that are basically impacting the real world of business by mechanisms of macroeconomic simulation. There are, there's simulation technology and game theory. There are things like pricing models. A few of you might recognize the equation for Black-Scholes there that determines the value of an option by a strictly algorithmic approach, by which you can, synthesize an equivalent instrument by means of a carefully constructed algorithm. And there are many other things. The little graph there shows the flash crash, which was an interesting phenomenon that's still being studied from an algorithmic standpoint. We all are aware that biology is basically becoming an information science, and there's a lot more to say about that, but I won't go into that here. There's even a lot of computational thinking that's invading things like the arts. And some of these are really quite interesting. It's often said that abstraction is the science of art, and other people say that computer science is the science of abstraction. So somehow in my mind that makes computer science be the grand science of art, or something like that. But there is a relationship there, and there are many interesting things going on, even in the sort of commercial sector. We see companies like Netflix and Pandora and so on that are building sophisticated models of people's taste to be able to predict what movie you want to see next or what kind of music you want to listen to. And so that is actually affecting the world that we live in. There are companies like CUHK that actually are building systems that are very sophisticated in modeling various aspects, including taste. And there are companies that are making real, go, no-go, green light decisions on whether to produce a film based on some script by, using CUHK's models, or whether to come out with a product, and so on. So that kind of impact is happening everywhere, and in many, many other arenas as well. We can also find some examples, some of them quite strongly motivated, of great thinkers who actually had some element of computer sort of algorithmic thought that we can discover despite the fact that they predate computers. So this guy you may recognize, maybe you don't recognize. In fact, it's James Clerk Maxwell, okay? One of the greats in physics. The great thing he did was to consolidate a bunch of work of others, of Ampere and Gauss and so on, into what we now call Maxwell's equations. We can kind of view those in retrospect as being sort of the lines of code that run the basic physical universe. So he looked at those lines of code and tried to make them look pretty and symmetrical and everything. And one of the things that ideas he toyed with is changing them just a little bit to have a sort of a symmetry between the handling of electric fields and magnetic fields. And this symmetry led to the idea that a changing electric field generates a magnetic field, and a changing magnetic field generates an electric field. Okay? So there's sort of a circularity. There's a self-perpetuating phenomenon that he predicted just because of this aesthetic fix he made to Ampere's law. And it turned out that that phenomenon he would propagate at some speed that he could predict because of his model, and that speed exactly matched the then measured speed of light. So there was a eureka moment, a big eureka moment in physics when Maxwell explained light, the propagation of light, as an electromagnetic wave. Okay, there are others that we can point to. Einstein has a whole host of them. One is this mystery that he was hell-bent to solve about why is the speed of light constant? Why do two people moving at different speeds observe some experiment, and to both of them, it looks like the speed of light is the same, okay? That's basically kind of an algorithmic mystery that he was able to solve by special relativity. And he asked questions like whether God plays dice with the universe, okay? A modern computer scientist would say, does the universe run on a randomized algorithm? Okay, there are some other examples that we can point to of places where there were great thinkers who obviously needed computer thinking, but didn't have it, okay? This goofy-looking guy turns out to be René Descartes, one of a very large number of very smart people who were completely baffled by this thing that they call the mind-body problem, okay? The relation between, the arrangement of atoms in my physical body and kind of the consciousness that kind of uniquely defines me. Okay, this was a great mystery in philosophy. I remember taking philosophy courses and studying it. It turns out that to a modern, educated computer hacker like me, okay, that's not a problem at all. By the way, this is a picture that Descartes drew to make the whole thing clear. It clearly didn't make the whole thing clear to me or to very many other people. But to a modern computer-savvy person, there isn't much of a problem, okay? We have much richer set of models. We know about hardware versus software, okay? We can understand about a process that has information stored as transient state and so on, okay? And all of this kind of goes away. We kind of can understand the distinction between the physical arrangement of atoms in a body and the sort of consciousness and behavior that they're exhibiting. So, in fact, this has become an uninteresting problem because of the impact of algorithmic thinking. Okay, let's mention a couple of things. The four of us are all university professors, and so how does this impact university education? Well, it is having an impact, and I'm going to just mention a couple of very quick data points. One is a proposal that was made by two of our colleagues, Professors Adler and Sussman, decades ago, that MIT actually teach electrical engineering, okay, not in the traditional way, but by teaching our students to write programs that simulate electrical circuits. And the theory was that if they really understood how to write programs that behave like electrical circuits behave, then they would now demonstrate the understanding of electrical circuits. A very interesting and radical approach, educational approach. It never quite got off the ground simply because MIT didn't want to, was conservative enough, maybe with good sense, conservative enough not to risk its #1 rating in electrical engineering on this kind of a very risky experience. I wish that we had found a way of doing that experiment, and things like that may happen in the future. Another thing that those of you who are intrigued by this might look up is there's a course that's gotten a lot of press taught at Princeton. It's called CUS 126. And what that does is it's nominally, I guess, a course in programming, but what it does is it has a series of labs that are fascinating, okay? These are the kinds of things that are done traditionally in sort of wet labs, where you take real hardware and you go into the laboratory and you make something happen and you mix things together and measure things and come to various conclusions about various domains in science. But each one of the Princeton labs does precisely the same intellectual exercise, but does it using computers, okay? It does it using simulation or other sort of programming aspect. And this is really the essence of computer science. And the essence of computer science, in my view, is the idea that you can understand something by some physical structure by extracting, by encoding that physical structure as a string of bits, as information, and processing the information rather than having to process the structure itself. Okay, very strong algorithmic thinking component to that course. Okay, there are various things happening in earlier levels in education. I'll just mention a couple very quickly. There are things, lots of languages and lots of sort of toy environments that are designed specifically to kind of enrich children's understanding of computer ideas. Many of us are familiar with those. There's a bunch of kind of online models and resources. Which one of my favorites is something called Computer Science Unplugged. I don't know whether any of you are familiar with that. But the thing that's interesting about this is a site that is dedicated to computer science ideas for kids. But it doesn't use computers at all. So it has sort of physical analogs that demonstrate these computer science ideas. Okay, and there are many others we could name, but one of my favorites is games. Okay, most parents I know object to their students devoting a lot of time to computer games, but I find that at least many of them are a really rich educational experience. Okay, many of them involve the simulation of some world, like the world of goo is one of these things. It's not a real world. It's not an accurate model of the physics of our real universe, but it is a world that has some model and some laws of physics, and the students, the kids who play with all of these simulations spend a lot of time kind of reverse engineering the rules that these universes run by, okay? They're actually learning lessons in computer thinking, although it's perhaps a little bit subtle and often escapes the attention of their parents. Okay, so for those of you who I haven't yet convinced I'm completely crazy, let's go to sort of the cosmic view of algorithmic thought in education. You're all familiar with these simulation games. Okay, we know about various sims and so on. There's hundreds of simulation games at this point. They have things like simulated people. We call them sims. The people actually have characteristics that are loosely modeled after real people. In many cases, they simulate hunger. They simulate pain. They simulate lust, love, and all kinds of emotions, okay? Now, it is true that all of these simulation models are very primitive. But, we've only been doing this for a decade or two. Okay? These simulation games haven't been around for very long. So they're kind of understandably primitive. But imagine, after another few decades, imagine 100 years of evolution of these games that have simulation models of people. These people would get more and more sophisticated. Maybe they'll get so sophisticated that they'll start wondering about the lines of code in their own implementation. Could that happen? Could they get that sort of reflexive instinct? Well, maybe they will try and understand the lines of code in the game and kind of reverse engineer the environment they're in. Well, one thing that we could kind of muse about is maybe that's the situation that we're in. Okay? Maybe our scientific exploration of physics is basically trying to understand the lines of code in the physical universe. Okay? Our study of DNA and its relation to our behavior, maybe we're sort of reverse engineering the code that implements us. Okay? So there's this sort of strange view that we have a universe that is following some algorithm, and we have gotten sophisticated enough that we actually can have as a goal the understanding of that algorithm and the prediction of its behavior. And there are all kinds of kind of interesting games we can play with that idea. We can imagine that, for example, the Big Bang, okay, we have a lot of evidence that there was a Big Bang 13.5 billion years ago, okay? Maybe that was just the time of the last reboot of the universe, okay? And maybe whoever it is who hit Control-Alt-Del and caused that reboot, maybe it was a 13-year-old kid, maybe it was a system operator in some higher level universe, okay? Maybe that's the person that some people call God, okay? Lots of kind of interesting issues, okay? Our prayers to our God, are they in the nature of bug reports or feature requests to whoever's kind of running the universe that implements our behavior? Well, you can listen to this and nod politely and say, this is just crazy. And you're right. It is just crazy. And on the other hand, one of the things I like to do is to defend craziness. So let me defend craziness a little bit. Maybe I'm defending myself in the process. One thing that's kind of fun to do is to take a bunch of ideas and put them on a spectrum that ranges from boring on the left to insane on the right. Okay, now we can all play this game and we'll all put ideas in slightly different places. Okay, but there are a lot of things we probably agree on. Okay, most of us will agree that accounting is pretty boring. Right? Have I offended all the accountants in the audience? And we might agree that invasions by space aliens, well, that's pretty crazy. Okay, well, suppose we start getting things that are closer to the center of the spectrum. Can we find a line that divides ideas that are profound from ideas that are just crazy? Okay? Where is that line? And my thesis is that there are things that are close to that line on either side of it. And there's kind of a fuzzy region around that line. But the things that are close to that line and on either side of it are kind of the most interesting ideas. They're the ones that we argue about. Is this a crazy idea or is this a profound idea? Okay? Those questions are the most important questions we ask in some sense. And I actually think that one of the great skills we can give our students is to be able to explore that center area of the spectrum, to occasionally go over the line and explore crazy ideas. Okay? That's the way in which they get to be able to distinguish crazy ideas from profound ideas, which is a terribly important skill. Okay, so creative thinking, I think, involves a lot of exploration on both sides of that boundary, and so I will forever defend the exploration of crazy ideas and the teaching of that exploration to our students. And I will argue that algorithmic thinking is an essential tool for doing that. Okay, so I don't have a lot of time left, and I haven't said anything about what we should do about all this. I'm rambling on. And one answer, I don't have a prescription, by the way, so this is a short one-slide pitch. One thing we can argue is we don't have to do anything. Okay? This is a movement that is more powerful than any of us. Okay? It's going on anyway. It's going to go on. It is a conceptual revolution that is inevitable. Okay? I believe all of that. On the other hand, I also believe that I want my children and my grandchildren to be kind of on the leading edge. Okay? We all want our universities to be producing the leaders of the next generation, not waiting until some other group of people leads them in the direction of computer thinking. So we kind of like to get a jump on that. Okay, so one thing we could do, the four of us are college professors, many of us here are college professors. One thing we can do is teach courses for sort of using computer science ideas at the university level. Well, that's pretty easy for us university professors to do, and a lot of people are doing that. The problem is that the people we get coming into a university like MIT, for the most part, already have gotten this skill. They already understand about computerized thinking and sort of internalized it. And in fact, what we need to do is to influence that pool. That we need to start much, much earlier. We need to get younger kids thinking in computer terms about various things. Okay, so the problem with that is that there's a sort of generational time constant. One of the things we can do is to make that happen is that as university professors, we can be teaching the people who are going to be high school teachers, for the next generation. But that's a long time to wait. We have to teach these teachers, wait until the old teachers retire and get replaced by the new teachers that we taught, and then wait till the kids that they teach get out into the workforce and start changing the world. Okay? That generational time constant is kind of a killer. So there are various things we can do to try and avoid the generational time constant. One of which is that we can make a movement to try and re-educate the current high school teachers. Take the high school teachers, give them courses, get them to think in computer terms more than they're doing now, and that probably is a help. Okay, there are a number of potential problems, one of which is that once we make our high school teachers computer savvy, they may all get job offers from Google at 3 times their salary and disappear from the teaching pool. So that's something to worry about. But basically, the thing that I think it's important for us to do is for us as university faculty and people with educational research objectives is to kind of fuel the fire. We need to develop tools. We need to explore ways of getting computerized computer thinking into our non-computer science curricula. And I think that is an important conceptual revolution. Okay, so just to kind of summarize, we have, from the world of computer science, we have new tools for teaching. We have new tools for learning. And I think that we have, as an equally important part of this triad, new tools for thinking. And that is, in fact, impacting what we should be teaching our next generation of students. Okay, thank you.
Thank you, Professor Ward. The next talk will be presented by Professor Alvin Learn, Dean of Faculty of Education, CUHK. Professor Learn's research interests include career development and assessment, school guidance, and cross-cultural and multicultural issues in education and counseling. Among the awards he received include the Distinguished Contributions to the International Advancement of the Counseling Profession Award from the Society of Counseling Psychology of the American Psychological Association in 2009. He currently serves as Chief Principal Investigator of a large project supported by the Hong Kong Jockey Club to develop an e-platform and e-resources to aid the career exploration of young people. The title of his talk is Technology Mediates Learning, Big Data, and Learning Outcomes, Issues and Challenges in Education. Professor Learn, please.
Thank you. Our esteemed colleagues from MIT, colleagues CUHK, I guess it's kind of scary standing here to talk about something about education because I'm not a technical person. So my talk will focus less on the science of computation, but more on the learning side. So my talk, the topic is technology mediated learning, big data and learning outcomes, issues and challenges in education. Let me see. It's not. Okay, I guess the objective of my presentation is to summarize research findings on the effectiveness of technology-mediated learning on education. How does e-learning or technology-mediated learning approaches affect learning and contributing to learning in the process? And to discuss the challenges that the education profession is facing in relation to the development of technology-mediated learning. Now, I guess I would like to kind of highlight some recent development, but recent means in the last maybe a few decades. Have you heard about Plato? Actually, Plato was regarded by some as the first e-learning sort of development. It was developed at the University of Illinois in the 60s, 70s. And actually, I was a student at the University of Illinois in the late 70s and early 80s. And I saw these Plato terminals, okay? And they were kind of mysterious, and I didn't know what they were. But they were supposed to be doing some teaching. And I found out later that these were terminals that offer courses to university students and even to high school and elementary students. And it was actually a very innovative device, and it was actually developed by the Department of Physics and Computer Scientists at the university. And they actually innovate many of the features that we use in teaching, including message boards, online testing, email, chat rooms, picture language, instant messaging, and so forth. So Plato could be the first e-learning device. Plato stands for Programmed Logic for Automated Teaching Operations. Okay, so at that time, there has to be a terminal in a room, in a computer room. But I guess over the years, things have changed, and students, learners can have their computers and have their own laptops. They can do learning in different places. And I want to highlight this person called Sugata Mitra. What the Suketa Mitra did, he actually was from India. He put up this little huts with computers on the wall. He called the hole in the wall experiment. And he found that actually by just putting these computers on the wall or on different locations, many poor children can actually learn quite effectively. So the first idea that he talked about is motivation. Actually, all students have the motivation to learn on their own. And then if we give them the tools, they can learn without a lot of direction from the teachers. And he called that minimally invasive education. He started in 1999, and he continued that. It was spread to some other countries. In 2013, Suketa Mitra actually presented a similar idea called Build a School in the Cloud idea. So if you watch the TED Talks in 2013, that was a couple of years ago, he actually won the $1 million TED Talk prize. And this is his vision. My wish is to help design the future of learning by supporting children all over the world to tap into their innate sense of wonder and work together. Help me build a school in the cloud, a learning lab in India where children can embark on intellectual adventures by engaging and connecting with information and mentoring online. I also invite you, wherever you are, to create your miniature child-driven learning environments and share your discoveries. Okay, if you go to the website of Suketa, you actually can find out how the study was progressing after he received the TED Award. And Khan Academy, now, there's another way, okay? We all know about Khan Academy. They do a lot of online tutorings, lots of videos in many languages. The idea of flipped classroom is actually proposed by perhaps one of the earlier proposal was by Khan. This is the impact. Video library, automated exercise with continuous assessment, and they have a lot of features and translated into languages. Even in Hong Kong, I think there are some secondary schools that are using the videos of Khan Academy to teach their students, to augment the teaching of the teachers. When Khan was interviewed by an Indian newspaper recently, he talked about the idea of flipped classroom, but they actually have moved further beyond the idea of the flipped classroom. He was talking about personalized education. Although some teachers have used Khan Academy to flip the classroom, I'm actually more excited about personalizing education, flipping the classroom, having students watch lectures and read text as homework and then solve problems or discuss the reading during class is not a new phenomenon. Literature classes have been using this method for centuries. The goal of One World Schoolhouse is to shift from a one-size-fits-all classroom to a more personalized model of flipping the classroom doesn't necessarily achieve this goal. For example, if all students are required to watch the same videos on the same day, they still are not learning in a personalized way. What I hope we'll see in the future is a movement towards self-paced, mastery-based education. I guess we all want to know the effectiveness of all these innovations on Khan. The US Department of Education is conducting a large-scale study using a randomized controlled trial research design methodology to study the effectiveness, focusing on mathematics between 2015 and 16. We have other developments to MOOC, Udacity offering nano degrees, Coursera and EDX offering lots of online courses, but are they effective? Can cloud school, cloud instruction tutoring, MOOC, intelligent tutors, can they replace teaching and learning in traditional school and classroom setting? Actually, this is not a very good question. I guess the better question is, what are the keys to making technology-mediated learning effective? How do they work with the traditional mode of teaching in the classroom? The interaction is most important. A scholar in education, John Haiti, he conducted a huge scale study. He actually looked into 800 meta-analysis related to education effectiveness in the last few decades. He took 15 years to do the research, okay? Meta-analysis is a way of looking into the overall effects of some intervention, not by one study, but by many studies. Actually, he conducted this study with more than 800 meta-analysis, and on computer-assisted, technology-assisted approaches, he identified 76 meta-analysis involving more than hundreds of studies. Actually, here 4,000 studies and 4 million students. And the conclusion is that there's no necessary relationship between having computers, using computers, and learning outcomes. There was no correlation between effect size and year of study. That means not the more recent study can produce better, stronger effects, but the effects is relatively stable across years, across grades and ability level of students. Well, actually, that was a very general conclusion, but here are some of the more specific findings. In order for e-learning to be effective, diverse teaching strategies have to be used. That means you're not just using one mode, okay? You can use other methods. They have to be used together to meet the learning needs of the students. Training in the use of technology as teaching learning tools, training the teachers, training the students. That means we have to give them some tutoring on how to use the technology. So not just the intelligent tutor that is computerized, but maybe the human tutor that can help the teachers and the students to learn how to use the technology. Multiple opportunities for learning, that means they have time, they're not under time pressure. They can use on their own time to learn, and that there are multiple avenues, opportunities for them to practice. The student or teacher is in control of learning. This is very important. I think in traditional education, the teachers, is the boss of the classroom and in control of the curriculum and in control of what needs to be learned. But having students to be in control of learning is very important. Peer learning to be optimized, that means students can learn interactively, with the aid of technology that has been made highly possible in the classroom as well as outside of the classroom. Feedback is optimized, that means you have channels to give feedback to the students and that they can improve. Feedback can be given, can be directed, can be sent from various sources, not just the teacher. The peer learning process could also generate lots of useful feedback for the students. And here is another, general conclusions about e-learning approaches. Drill and practice computer-assisted program not effective. The challenge is how to make, if we still believe in drill and practice, that we need to see how they could become more effective. Drilling is not very useful. Constructivist use of technology produce positive effects. That means we need to engage students to create things, to put things together, to innovate, to create new things. That's important. That is a lot more important for the future global economy than just consuming knowledge or regurgitating knowledge. Computer laptop home ownership increased, high school graduation rate. If they have computers at home, they're more likely to graduate. That means computer can help the students to learn, okay? Now, following are just some main conclusion from John Hatie on education, not just on, the technology-assisted instruction. So these are more general conclusions, but I think are relevant to our topic today. Teachers are among the most powerful influence in learning. From his years of looking into the meta-analysis, this is one of the, age-old, belief that we tend to have, is that teachers are among the most powerful influences in learning. So if you want to make e-learning effective, then I think engaging the teacher is important. They're not going to replace the teachers. The technology and the teacher have to be together. The teachers need to be directive, influential, caring, and actively engaging in the passion of teaching and learning. That means in addition to having the hardware, the teacher themselves, their characteristics, the passion that they have, that they can express in teaching is as important. Okay, directive, influential, caring, and actively engaged. He concluded that teachers need to be aware that every day in their teaching, they have to teach students how to think, to construct meanings, and use meaningful experiences in light of the knowledge that they teach, so that students can move progressively through the curriculum levels. And I am sure that instructional tools, technology, have a lot to offer to improve that. I guess John Hatie also is a proponent of impact and evidence-based learning. One of the key words that he used throughout the book that he wrote was that you need to know the impact. This is where big data may fit in. Effective teaching are not tied to specific teaching strategies, rather that effective teachers focus sharply on evaluating the effects they have on students and adjust teaching methods accordingly. That means the teacher has to be someone who can use multiple sources of data to assess how they do. I think in the future, Helen talks about the big data, all sorts of data that are available. I guess the point that I want to make is that, very soon, maybe today, every one of us, all the teachers, students, have to become a data analyst. That means they have to be able to consume, understand, and derive meanings and identify actions from the data that they have available from the various sources. John Hatie talks about visible teaching and learning. This is actually the title of his book. When teaching and learning are visible, that is, when it is clear what teachers are teaching and what students are learning, student achievement increases. So the key words is visible teaching and visible learning. What is visible teaching? What is visible learning? Visible teaching, when teachers see learning through the eyes of the students. You meet the needs of the students. Visible learning, when students see themselves as their own teachers. That means they think they can handle the process of learning and become their own teacher. That is very important. So visible teaching and visible learning. So I guess with this little time that we have, I want to talk about challenge. Challenge one is that, how do we design and optimize the architectronics of school for teaching and learning? I guess you have probably not heard about this term called architectronic. Architectronic refers to the learning environment today. They're not confined to the classroom walls, to the school, but to the space that students are engaging in the theaters, live theaters that they play their life roles. How do we make use of the school premise? How do we engage students to learn at home and in other places? The key word is the learning community. The community consists of students inside and outside of the classroom in the community. How do we design and optimize the architectronics of schools using technology, using classroom, using teachers, using various agents of teaching in our community and parents? How do we engage learning technology so that the students, not the teachers, in control of learning? This is actually a conclusion that John Hatie drew after looking into many studies. Learning technology should facilitate and enhance the powerful impact of teachers, not to replace them. How do we facilitate teaching and learning in the new classroom so that learners are co-designer of knowledge and learning, making use of all the interactions that are made possible by technology. 3 is knowing the impact. I guess I don't have a lot of time, but I guess the idea is that there are many data available. They're untidy, they are not consistent, they're hard to read, but then we have to train all of us, all the teachers and educators and students to try to understand from the massive data that we are gathering, not just the traditional assessment data, but other types of data, including how we learn, how we enhance the competence of students on the 21st century skills. These are the 21st century skills for your information. And the idea that all of us have to be a data analyst. Okay, lastly, how can we structure the new learning such that it can be transformative to all? I think this is the most important question. Education should be transformative. So we are not just happy with the status quo. We are not just happy with owning the knowledge. We want students to not just become a consumer of knowledge, but someone who can develop, who can discover new knowledge, who can innovate. So we want to, in order for that to be education to be transformative, learning technology to be available to all, inclusive education, building on the strengths of learner diversity, to develop learners who can navigate change, discern meanings, negotiate diversity, and create and innovate would be the most important goal of education. And I'm sure that technology has a lot that can help in the process. Thank you very much.
Thank you, Professor Learn. This will be the end of the first session. We will now have a coffee break at the foyer outside the lecture theater. Please help yourselves. The next session will begin in 10:30. Thank you. Welcome back again after the coffee break. The next session of the workshop begins now. We are honored to have Professor Chris Thurman as our second MIT speaker. Professor Thurman is the Director of Academics, MIT Ethics, and Senior Lecturer in the MIT Department of Electrical Engineering and Computer Science. He has 4 decades of experience as a teacher, digital system designer, courseware developer, and entrepreneur. Professor Thurman's research has been in the areas of programming languages, compilers, and computer-aided design tools for integrated circuits. Most recently, he was the research director of the MIT Cumulus Education Project, a research collaboration with Quanta Computer Inc. focused on the development of cloud-based educational technologies. Professor Thurman received his BS in physics from Wesleyan University and headed to MIT for graduate school in 1973. He completed his MS, EE, and PhD degrees in computer science and engineering and subsequently joined MIT's EECS faculty. He escaped from MIT in 1985 and tried his hand at being an entrepreneur before returning to MIT in 1995. He's an avid hiker and enjoys guiding summer walking tours in the Swiss Alps. The title of his talk is See One, Do One, Teach One. Professor Thurman, please.
Thank you. I'm glad to be here today. It seems we have many shared interests, and I hope over the next couple of days we'll get to explore those further. A few years back, we were invited by the chairman of Quanta Computer, Chairman Barry Lamb, to think a little bit about how computers could be used to make education more effective. And we sort of rolled up our sleeves and began to think a little bit about what were the places that computer technologies might have an impact on the world of education. We've heard a little bit about self-paced mastery learning. That's sort of the gold standard for group education. It does almost as well as a one-to-one individual tutoring if it's done right. My particular interest is in the world of hands-on learning, active learning, getting students to actually build things, which I think is the way I always learned how to do stuff, and I like my students to do the same thing. I think computers have a chance to really provide wonderful environments for doing both of those things. In business school, they teach you that you are what you measure. In other words, if you can't measure it and see what's going on, you have no way to improve on the system because you don't have any information about sort of how the system is working so far. So the MOOCs offer us really our first at-scale educational laboratory where we can propose experiments and perform them with hundreds of thousands of students. And that's really quite remarkable. For a scientist or an engineer, that sort of ability to do educational experiments means that we'll be able to measure results and actually target improvements for the first time. In the area of interactions, so much of educational material is in the natural language. And so we have forums, we have book chapters, we have audio-visual materials. Processing those so that they're accessible to the world of search and summarization is something that we've had a long-term expertise. Professor Zhu will talk about a little later today, about using human language technologies to make some of these new types of interactions accessible to students. Online, we have an interesting issue of how to build learning communities. And in particular, how to engage learners to help one another in learning. If all of us who have had a chance to live in college dorms know that a lot of our learning happens because somebody down the hall could interact with us and explain what is going on. And I think that how do we create those sorts of environments, perhaps asynchronously, in the world of computer education, online education. Finally, there's a lot of types of new content that it takes a lot of work these days to author an online course. I've worked on 3 over the last couple of years, and it's a labor of love. We need to make that much, much easier for people to be able to contribute material, learning, teaching material in some of these new frameworks. We have to make that a much lower bar so people can clear that hurdle quite well. One of the things that is interesting when you're setting off to think about how to construct educational materials is what is your philosophy of education? In other words, how do you think people learn, and then how are you going to structure your materials so that people can learn that way? And I like to borrow the phrase from medical school: see one, do one, teach one. Initially, your first job is to, if you're sort of a novice, you need to learn the concepts and observe, things being demonstrated, techniques and skills being demonstrated. You often get your first handle on how things are put together by analyzing things that already exist. A particular mathematical proof, a particular medical procedure. These are things that you sort of figure out why they worked, how, and things like that. So your job as a novice is to understand what is going on. As you progress, you get into the do one category, and this is to use so novice, apprentice, master is sort of the language of the guild halls in Europe in the Middle Ages, right? So how did somebody learn a trade? Well, they went through these 3 steps. So the apprentice step is that you're for the first time actually taking the concepts and skills and you're using them yourself. Rather than watch them happen, somebody else do them, you are for the first time saying, oh, it sort of looked easy when Steve did it, but now that I'm doing it myself, is actually, it turns out to be a little bit harder. And so maybe for the first time, you're actually creating things. So rather than analyzing other people's artifacts, you're beginning to synthesize your own. And so you begin to realize how things are worked. Because you're putting them together yourself, you know how they work. And then finally, at the mastership level, your job is to teach these concepts to other learners. And in fact, as you'll see a little later on when I talk about teaching teaches the teacher, teaching is actually something that we don't actually ask many students to do now, but most of us who have done a lot of teaching sort of appreciate how much better we understand the material because we've had to sort of organize it and make it accessible to people and explain why things are the way they are. And I think that, if you looked at Steve's sort of spectrum of levels of understanding, I think explaining why something is true is actually pretty high up in my list. If you can do that, then you probably have a very clear idea of the concepts from soup to nuts. Okay, so how do you design an effective learning sequence online? Well, the current favorite recipe is basically short videos followed by interaction. So it's a little hard to see here. This is an edX page. There's a bunch of video segments, and then occasionally there is an opportunity to stop and ask fairly simple exercises just to have the student engage in the material. So we're all sitting here patiently listening to lecture. But what would be really hard is, well, not hard, but what would be great if there was a way in which you could stop and do a little bit of interaction every 5 minutes or so. Your concentration level would go way up. And in fact, one of the things that we experience in the flipped classroom is exactly that sort of effect. So we keep doing this. So what used to be an hour lecture is now a whole set of very small video sequences with opportunities for the students to actually do a few simple exercises after each concept is introduced. One of the things that we don't really pay a lot of attention to as classroom lecturers is what people should do with their eyes during an online learning experience. Right? What happens is, as soon as there's motion on the slide, you are watching that. We're visual beings. We're trained to watch things that move. In a lecture hall, I'm here moving, and so you're watching me. You can't really help but to watch me. You're physiologically built to watch moving things. Over here, on an online thing, it can be deadly dull to watch one PowerPoint slide sit on the screen for 10 minutes while somebody drones on. Right? So the question is, how do we, as teachers, we have to start working on creating materials that are much more lively in that sense. And the reason is that we don't have a captive audience. In other words, somebody who's watching our stuff online can quickly go do other things online. So what you want to do is to make it so interesting that they really want to hear the end of that story. Right? And that's a challenge because we're mostly used to people who, you're trapped here for the next 20 minutes. So, if I'm a little boring in a piece of it, you're not suddenly going to click away and you'll never see me again. So, here's some interesting data. So we're starting to get some data back from some of these courses. If we look at this thing about why people watch videos, you can see up to about 6 to 9 minutes, most people watch the whole video. However, if you created a 40-minute video, on the average, people watch 4 minutes of it. Okay, so that's, on the other hand, and here I am, I'm a practitioner, like you probably know, the hour lecture, right? And I'm suddenly realizing, wait, 4 minutes in, most of the students have stopped listening? That's not so good. So the idea here is we're beginning to get some idea of how people engage with the material, and we want to shape our material a little bit to sort of match up with how they're going to engage with it. Our big goal, or one of our big goals, is to achieve mastery learning. And mastery learning is the idea is you're going to work on a concept until you've got it. So, here's the standard bell curve of distribution showing, the grade distributions in a sort of a standard class. Our goal is to take the people who don't do so well on those assessments. And it wasn't that they're dumb, okay? It's just that they didn't get that particular concept in the 5 minutes I talked about it. What we want to do is to take those guys and basically figure out how to let them at their own pace master the material, and hopefully, collectively we'll all do better. So the good students are okay. What's hard is the students who didn't capture a concept before we moved on. The trick is not to move on before they do that. One of the challenges is coming up with assessments that help people judge their mastery. And in fact, you have to come up with many assessments because they want to, they didn't get it the first time. They want to come back and see a new question to see if they have mastered the material. And so one of the things that we've been working on recently is creating adaptive hints. The CMU had a great project, the Online Learning Initiative, which really pushed these, and we're starting to put these into the platforms where, depending on how you got the answer wrong, we will tell you something, we'll have a hint that's specific to that answer. So I can look at all the wrong answers for a particular question and start developing hints for people who got particular classes of wrong answers. So a key to mastery is not whether you got the answer right or wrong, but when you got it wrong, somebody tells you, maybe you forgot to think about this. So we're trying to make the online platforms do a better job of that. The big problem with self-paced is that it's hard to basically keep people moving along. If I can do it any time I want, maybe tomorrow is when I want. Today, I'm busy.
And we all face that. We all have busy lives. And so deadlines are actually, everybody goes, oh, deadlines. We shouldn't have deadlines in self-paced. But deadlines are what most of us respond to in, figuring out what we have to get done today. So trying to think of a way to introduce deadlines into a self-paced program, it seems a little bit of an oxymoron. But I think we can sort of build individual deadlines based on watching a student work. We can guess how long they should have for the next segment. OK, so if we watch this guy, he's busy trying to type in a bunch of answers to figure out the thing. He doesn't know where that 2 goes. Which part of the chemical equation should that 2 go on? And he's basically, by sort of fooling around, he gets immediate feedback. So rather than writing down a p-set answer and then coming back a week later to just a problem set, I'm sorry, we call them p-sets where I come from, coming back a week later and getting the graded homework, you can find out right away whether it was, you have the right concept or not. So this immediate feedback is very good. You have to be careful, though, that we don't get into this guess and check, loop. And it's funny, I can replay, the students in sort of real time. I can look at the logs and replay what they do. And you can see students who are guessing and checking. 3, check. 4, check. 5, check. They're just trying to find out what, I just want to get the green check mark, thank you. We need to figure out ways to avoid that. In this sort of strategy. So immediate feedback is very positive. People really love the power the feedback gives them to judge whether they know the material. But the flip side of that is that people get so focused on, do I have the right answer, that they don't really, they're not putting the time in to learn, they're just putting the time in to guess, which is not our goal. Here's the part I really love. I think Craig and Lonhart said it really well. The learning and retention is related to the depth of the mental processing. So how do we get deep mental processing? Right? How can I get you all to be, doing deep mental processing right now? And the answer is I would have to give you probably a hands-on activity. Right? Listening is often not a deep thing. Sometimes it's thought-provoking. Sometimes the lecturer is energetic enough that you're at least paying attention. But these sorts of hands-on activities are all different ways to engage different aspects of learning. So in this thing here, the idea of sharpening your intuition. So many scientists and engineers, they're very smart. They know about all the mathematics. But the key to innovation is having a good intuition of about how things should work. And sure, you might have to use math to get the right answer. But it may be in something like this. If I had told you, for example, what would it take to get the electrical field vertical right at that point? Right? And now you'd have to start thinking a little bit about how do I place the charges? How does the electric field, in sort of general terms, how does the electric field formed by the charges? And now I'm getting you to think about what I want you to think about. Right? And so it's not only just something to play with, but I give you a little challenge to go on with it. And all of a sudden you're experimenting. Right? You're being a scientist. You're beginning to try to feel about how things should work. So sharpening your intuition is an important part of hands-on. Another important aspect of hands-on is muscle memory. We've all learned that if we take notes, I'm down here in front of the audience taking notes, not because I'm going to spend a lot of time referring to those notes in the future, but the fact that I'm writing them down, particularly the points that really appeal to me, that's the thing that will cause me to remember it. And so this notion here of there are certain tasks that if you use your muscle memory, like crumbing up with these chemical structures, if you actually involve you're moving your arm, or in this case your mouse, to put things together, you will remember that chemical structure in the future. I can show you lots of slides of chemical structures. It would have no impact. If I tell you to draw them yourself, you will remember it. Right? So coming up with hands-on exercises that let us exercise our muscle memory is, I think, an important thing. Here's the hardest part of hands-on, starting with a clean slate. Right? I teach a course that teaches this material, and this is some student visibly working away on creating a particular circuit that has a particular functionality. But starting with a fresh piece of paper where you have to decide, what do you do first? What do you do second? How do I know I'm doing the right thing? organizing the drawing the way that it makes sense, that you can see that it's right, that it's not just a garbled mishmash of gates. And so it's this sort of design activity that most students identify as really being there. We talk a lot about logic, but there's nothing quite here. Got the bug. There's a bug in his circuit. He's going to have to fix it. They're, for the first time, able to actually feel like engineers or feel like scientists or something like that. So the idea is we're giving people a chance to actually exhibit the behaviors we're trying to teach them. And so that's a very powerful reinforcement. Okay. The challenge in these sort of online environments is how do we give over-the-shoulder help? You're having a trouble with this circuit. How can I, as an instructor or one of your peers who's finished the problem successfully, look at what you're doing, right? And so, we already have some solutions in hand, right? Google Docs allows all of us to share the same document. Well, we want to bring that technology to all the sorts of online interactions here. So it's possible for people to collaborate in a shared space like we would if we were sitting next to each other, at a desk in a dorm. Now we can collaborate online in much the same way. And we have those tools. They're just getting them onto these systems, into the educational platforms is an ongoing challenge. Okay, teach one. We don't often ask students to do much teaching. You just have to learn and do, or see and do, and then you're done. I think that asking people to teach is super important. So here we have forums in which there's a small class of students who clearly have invest a lot of time in coming up with very good answers to questions. And first of all, it's nice to go and find those students and say, I want you to be a teaching assistant for my course, okay? But more importantly, a student who is able to generate that sort of answer clearly understands what's going on. And my guess is that in the process of writing that, maybe for the first time, they actually organized their thoughts and they were able to articulate them in a way they never bothered to for themselves, right? It's funny when you start talking to other people, now you're putting them in a rational thought, whereas they're sort of jumbled inside your head. Now they're organized. So this sort of thing is super, super great, and we need to be able to make this as much a part of you taking a course as you are, you're doing the homeworks. Of course, the challenge is how do we do this with all the people taking an online course? The forums are a real mess, tens of thousands of posts. How do we come up with a way in which smaller groups of students can have meaningful interactions with each other, some sort of cohorting strategy? Do you have a question or no? Oh, you're just, yeah. Okay.
So you seem to be assuming that the ability to organize knowledge well can be taught to a large number of people. Does that match your teaching experience with this?
So I think some people just do that right. Naturally. Some people do it naturally, and I think if you can do it naturally, more power to you. But I think if you watch other people, so if you watch me organize the material for somebody, after a while you'll be able to basically channel the inner Chris, right? And I think I've seen students who've only done a mediocre in my course come back and be excellent LAs, because they started to internalize how to explain things to people. And in the course of doing that, they learned how to explain it to themselves. They actually mastered the material through teaching more than they ever mastered it through the actual learning process themselves. We have a system where students are able to add hints about things that are going wrong, particular tests. And so students can go look up. They can say, I'm having the same bug here. Maybe I can go get a hint as to what's wrong. And the students are very good about the hints. They try not to give away the answer, but they try to be constructive about things you might go look at. So I think that's turned out to be a very powerful tool for students to help each other. And I think Rob will say more about that a little later on learner sourcing. Towards the end here, reflect and advise. So one of the things we don't often do is once you've finished your answer, we don't ask you to think about it much. You say to work, what do I have to think about? Well, here the students, once they finish their answer, are showing designs that are both worse, that have, in this case, a bigger size than the one they designed, and also one that has a smaller size than the one they designed. And they were asked to give advice. What would you tell students who had done worse than you or had done better, and what would you tell yourself to be able to get the best design. So we're actually getting them to think about how they could have done better. What does better mean, and how would you explain to somebody how to do that? And so we get these great comments coming back. And so the reflection is not only good for the individual student, but now we can start use these as hints for people who are having problems in doing the design. If we look at an online course, how do students invest their time? And you look here, this is the data from an electronics course that was taught on edX. It was the first edX course that I had the honor to work a little bit on. And you can see that certain activities are pretty constant. The notion of spending about 2 hours a week watching lecture videos, and there were 2 hours of lecture videos to watch each week. So you're saying, wow, that's just exactly what I thought. There's other things here which actually sort of go, wow, look at that homework. See the homework really drop off toward the end? Why was that? Right? There must be something about those later homework problems that maybe people just were maxed out and couldn't put in the time. So being able to measure how people are using the materials turns out to provide the teacher some insight into what repairs they need to make to the course in order for the right thing to happen in terms of outcomes. What's interesting to me is there's certain things here that we thought were important, like the book. There's actually a Elsevier textbook that goes along with this course, which turned out to be not very referenced at all. And you're sort of going, oh, God, I would have thought the book would be much more important. So we're getting a sort of a sense now of what users really think is important rather than what we as teachers think is important. We prepare many, many different materials, right? We have online lectures, we have the lecture questions, we had labs, we had homeworks. You know, how did people engage? So the charts on the right are sort of show you what percentage of the people who finally earned a certificate, how much of those they did. For instance, you know, you look and you can see there about 3% of the people who finally earned a certificate watched, 83% of the videos. More interestingly, so some of these things you can see there's bumps in. Other things are pretty uniform. In other words, people, and so lines that basically go from the upper right down, the upper left down to the lower right is basically a fairly uniform distribution of people who are equally divided about how much of the resource they used. Lines that stay high are material that were used by everybody almost 100%. Those seem to be the materials you'd want to emphasize. Right? So those are the ones that say, wow, I've hit a sweet spot there. Let's do more of those and less of some of the ones that no one bothered with. It's interesting to see how people are assessment driven. This is not really much news. The circles show the amount of time they spent. So on an average homework, on the midterm exam, on the final exam, you can see the final exam was about the time they spent on it was about twice what they would spend on a homework. But then you see why they were doing that. What did they go look at? Right? So they can go look at all the online materials. And you think we're giving lectures, right? We say, wow, lectures are so central to the course. Lectures don't rate very highly as the go-to resource when somebody has a question they need. I don't know how that works. What's interesting is that the discussion forums and the homeworks and the labs tend to be the places people go and says, that's where I saw that. I'm going to go look at it again there. So we're starting to realize that maybe what we should do is reorganize things a little bit to give people the problems they need to solve first, and then give them the materials they need to solve it. It's sort of fun to think about how to reorganize teaching. And let me just finish by this. I was resonated with the earlier talk by the dean about the importance of teachers, right? It turns out that about a quarter of the certificate earners in edX, are actually teachers who are teaching that subject, right? And what they're doing is, it's interesting to speculate why it is they're engaging with the online course. They know the material. Some people are just trying to say, I'm just checking to see if I still have all my skills. Maybe they're looking for new material, right? Maybe they're trying to say, is this presentation better somehow? But I think there's a real opportunity here as people who are putting stuff online to actually focus on what this huge cadre of teachers would find really useful, in terms of things they could find online that perhaps they can adopt and use in the courses. So let me just finish up by saying, look, we have a lot of exciting things happening online. We get to re-engineer so many different aspects of the educational experience as we move it online. I think that we're discovering that the most effective types of online materials are not simply the repeats of what we've done in real classrooms. Maybe that doesn't surprise anybody. But it's a fun adventure to start thinking about what we should do in the future that's so different than what we've done in the past. Thank you.
Thank you, Professor Thurman. The next talk will be presented by Professor Chi-Yu Chiu, Dean of Faculty of Social Science, CUHK. Professor Chiu is an internationally renowned behavioral scientist. He received his PhD from Columbia University, New York, in social psychology, and is currently Chairmanly Professor of Psychology. Professor Chiu has created several new fields of investigation in basic and applied social science, including multiculturalism and creativity, and polycultural psychology. The rich implication of his research on the development of personal, social, and cultural competencies has been extensively explored in education management, marketing, legal studies, arts, sports, communication, and international relations. Being an active researcher, Professor Chiu owns an impressive record of research awards in publications with significant impact. He is also an innovative and passionate educator and the winner of several outstanding teaching awards at the universities he taught. Professor Chiu possesses extensive academic management experience. During his early years in the University of Hong Kong, he served as the Associate Dean of the Faculty of Social Sciences and as the head of the Department of Psychology there. He was the founding director of the Cultural Science Institute and the research director of the College of Business in Nanyang Technological University. He has actively contributed to the academic community through his editorial roles in reputable journals and book series. For 8 years, he has collaborated with Chinese Academy of Social Science to offer voluntary research development training to Chinese social scientists in mainland China, Hong Kong, Taiwan, Europe, and Australia. The title of his talk is Connecting Cultures, How Collaborative E-Learning in Social Science Education Can Facilitate Development of Multicultural Competencies. Professor Chiu, please.
Thank you very much. Thank you very much for the kind introduction. Good morning, everybody. It's really a great pleasure to be able to come here today to share with you some of my ideas about how e-learning and data science together can actually inspire new research and offer better answer to research questions in social science, as well as promote the quality of teaching and learning in the university. So one of the burning questions that I have been trying to answer is how we can promote student creativity through collaborative learning. And I've been working closely with Dr. Letty Kwan, who is in the audience as well. So today, what I'm going to do is actually to tell you some of the ongoing ideas that Dr. Kwan and I have been working on. If there is any like clear division of work between Dr. Kwan and I, the division of work is quite simple. She did all the work, and I take the credit. So I want to begin by saying that by pointing to a very obvious trend, and that is globalization have increased the level of cultural diversity in the environment we are living in. So this is the data from a recent study carried out by TWC on talent mobility. And what you see in this figure is increased mobility of talents across different continents. And we expect this trend to increase in the future as well. And this is another data slide from the same study. So what they asked in the study is how willing or how desirable it is for the younger people to have a career in which they have the opportunity of having a foreign assignment. And what you see from this figure is that nowadays, our young people actually feel that it is a good thing to have the opportunity to have a foreign assignment in their career. So that means increasingly, we will be working with students from different countries in the same classroom, in the same learning context. And we'll be interacting with teachers from different cultural backgrounds. I'll skip this one. So the next question is, okay, what does this cultural diversity have to do with creativity? And before I answer that question, I want to share with you why I am so interested in creativity and innovation. So this is some data from Google Books and Graham Wheeler. So for those who are familiar with data sets, you probably know that Google's Books is now offering this online search platform for us to find what are the trends of intellectual curiosity over the years. So what you see here is a search on the books published in simplified Chinese. And this is the data from 1900 all the way to 2008. Of course, I think the data are interpretable only after 1949, okay, when China, when the Republic of China was established. And the data here tells you how frequently a certain search word appear in the Google Books published in simplified Chinese. So if you look at this data, it tells, okay, I'm sorry for the Chinese characters you see here. So here it refers to intelligence, basically how frequently you will find the word intelligence in the Google Books, in the Chinese books. And you find out that there's an increasing trend here, and this is intelligence and wisdom. So the frequency is higher, and the gap represents the frequency of mentioning of the word wisdom in the books. And this is achievement or success, and you get a higher frequency here. But what is really interesting is this 9. This 9 refers to how frequently words related to creativity and innovation appear in Chinese Google Books. And what you find here is an increasing trend since 1978, when China started its open door policy. If I overlay this figure with another curve after 1978, and that curve tells you what is the GDP per capita in China. You see almost perfect overlap between the two curves. So there could be many different interpretations of the results, okay? The one that I prefer is that creativity is the driver of progress, particularly economic progress in a country. And so as the country makes progress in its economy, people get inspired by the progress and want to know more about the driver of the progress. So that's my interpretation. And of course, you probably have come up with, you may have like different interpretation. Now let me return to the issue of cultural diversity. So how does cultural diversity present opportunity and obstacles to the development of student creativity in collaborative learning? So the first argument I want to make is that cultural diversity is both a source of inspiration and an impediment of creativity and innovation. Today, I understand this is a talk for the general public, so I'm not going to tell you or present to you the technical details in the studies. I'll just give you a few examples to illustrate this point. So if you're now in Hong Kong, and if you go to Disneyland, you'll find there's design for the yin and yang Mickey Mouse cookies. So what you see here is a hybrid presentation of the Mickey Mouse and the yin and yang symbol. So Mickey Mouse is a symbol of American Disneyland culture, and the yin and yang symbol is a symbol of traditional Chinese culture. You put two symbols together, you come up with something like this, which could be quite creative. And here's another example, which you can actually buy in the store. So this is the Haagen-Dazs mooncake ice cream. Okay, for those who are familiar with Chinese culture, you'll know that mooncake is a favorite dessert during the Moon Festival in Chinese culture. And if you put these Chinese symbols together with a Western product, ice cream, then you get this very innovative products. For those who like fashion, Shanghai Tan is another example of mixing cultures together. Okay, so mixing Chinese fashion with Western style fashion. Now, that is the positive side of culture mixing. And here is another example of culture mixing that create completely opposite effects. So in year 2008, the Starbucks coffee, the Starbucks cafe in the Forbidden City in Beijing was forbidden in the Forbidden City. So, and why is that the case? Okay, if you look at what are the online messages that really trigger this exclusionary reaction. This is a paragraph in the online message that trigger the negative reaction. The Forbidden City is a symbol of China's cultural heritage. Starbucks is a symbol of lower middle class culture in the West. When I taught this material in the US, the students complain a lot about this characterization. They love Starbucks coffee. We need to embrace the world, but we also need to preserve our cultural identity. There's a fine line between globalization and contamination. Please don't interpret this as an act of nationalism. It's just about we Chinese people respecting ourselves. I actually like drinking Starbucks coffee, and I'm just against having one in the Forbidden City. So this happened in 2008, but history tends to repeat itself. So this is what happened a few years ago in Hangzhou, in one of the really sacred Buddhist temple in China. And so what happened is that, Starbucks is going to open a coffee shop near the temple. And then in the Shanghai Daily, they once titles like this, "Culture Debates Get Heated as Starbucks Open Near Temple." And People's Daily online have a title like this, have an article with this title, "Why Can't Starbucks Lie Beside Ningyan Temple?" And there are pictures like this on the internet. Okay. So that tells you something, okay? That tells you something interesting about the effect of cultural diversity and creativity. It could lead to creativity. Cultural diversity could increase creativity. But at the same time, cultural diversity, if it is not managed properly, could also lead to intercultural hostility. Okay? And this is not just a Chinese phenomenon. Remember a few years ago, the debate in New York City about building a mosque near Ground Zero. Okay? And this kind of culture mixing didn't really elicit very favorable reaction from many Americans. So that means, okay, this is a Lerdy slide that summarizes what we find in our findings and research, but I think the general message is that don't take it for granted that cultural diversity will always lead to favorable learning outcomes. It may not, unless it is managed favorably. And we can go beyond national culture and look at functional diversity. Nowadays, we like to talk about interdisciplinary collaboration. We like to talk about interdisciplinary learning. And we try to put students from different disciplinary backgrounds together and hope that they will learn better, they will become more creative. And the answer for that is yes, it may, but sometimes it doesn't. As an example of the efforts that have been launched to promote interdisciplinary learning, NSF in the United States have one workshop to promote interdisciplinary research and education in the graduate school. And they also recognize that, this is not something that can be done quite easily. So this is a cartoon, which I like a lot. I am on the verge of a major breakthrough, but I'm also at that point where chemistry leaves off and physics begin. So I have to drop the whole thing. So what does this mean? That means sometimes it's just too difficult for people to really move out of their comfort zone in their own discipline. And when it comes to interdisciplinary collaboration, we sometimes have this, what we call intellectual centrism. We believe that our discipline is the best discipline in the world. And the criteria of validity in our discipline is the only legitimate and valid criteria of validity in the world. And this problem is also recognized by the NSF in the United States. Means this is a very interesting picture that depicts one of the challenges in science and technology development in the United States. So in the United States, you have wonderful universities like MIT, doing really cutting-edge research, inspiring the world and educating the world. And you also have like a great company like Google's, like Apple's, who are extremely successful in commercialization. But then in between, you have a valley of death. That means nobody is interested to build the connection between academic research and industry. And there are good reasons for that. And these are some of the variables or some of the factors that have been identified. But one thing that is interesting here is culture, differences in goals and timeline between science and technology and acquisition management. I'm not going into details about this. We have written quite a bit about this. But what I want to do is to quickly offer my thoughts on how e-learning and data science together can help us solve this problem. So these are the opportunities offered by e-learning. E-learning offers opportunity for collaborative learning across cultures and across disciplines, which I think is really fantastic. If we have a course that is launched online, that's mounted online, and students from all over the world can take the course. And if we can design collaborative activities so that students from different cultural backgrounds and students from different disciplinary backgrounds can work together to accomplish something creative and innovative. This would offer a very interesting opportunity for us to observe their behavior. And we can assess their learning outcomes in terms of the level of creativity and innovation of the work. And more importantly, now we have a way, a platform to track the learning process of the student teams as they develop their innovative product. This is not possible in the past with traditional platform of doing research. But now, with all this discussion that is recorded online, we have big data that we can use to really study how a creative idea starts to emerge, develop, and be selected for further development. Now, there could be many different ways of doing that. What I'd like to share with you is some analysis that we have done using the big data to look at something that psychologists, particularly learning psychologists, are very interested in, and that is what kind of questions students tend to ask and at what time. As a preliminary test, we have data collected from Singapore. That was the case because I was in Singapore when the study was conducted. So we collect tricks from the beginning of 2011 to the end of August of the same year. And then we have really a lot of the data that we can use. What we did is we code those tricks in terms of whether or not the tricks actually contain a question. And if it contains a question, what type of question it is? Okay, is it a question about who, when, where, what, or how? And each type of question are getting at different things. And then I'm not going to bother you with the technical details as I mentioned. This is the distribution of the questions across the sample, and this is the distribution of the total distribution of the questions over a week. So what you can see here is that people are more intellectually curious on Tuesday and Wednesday. It's a good thing to have this workshop on Wednesday. Okay. But then it starts to drop on Thursday, Friday, Saturday, and Sunday. You have the record no in level of intellectual curiosity. And this is somewhat refined data, which tell you how we can actually use this big data to check how people ask questions, what kind of information they would want to get during a week. So again, it tells you that, Tuesday and Wednesday is probably a good time to have a workshop because that is the time when people tend to ask a lot of questions about why, which pertains to meaning. People are constructing meaning on Tuesday and Wednesday, okay? And then they are also asking questions about what, okay, resourcing on Wednesday. And they want to know people on Wednesday. So they ask a lot of who questions. And what is interesting is that people tend to ask the how questions on Monday and Tuesday, how questions about operations and procedures. Where? On Friday and Saturday, I expect that you will ask this question more often. You want to know where to go in the weekend, okay? Now, these are just like some indications telling us that this kind of data could be very helpful and very meaningful for researchers to understand how people engage in different forms of information processing over time. Imagine that we have these tools available to me and the data available to us. And now we can track over the course of a project development when creative ideas surface, when creative ideas get selected for further development and elaboration, and what kind of pattern of information processing or search accompany each stage of creative idea development, and how each of these patterns help us predict the final outcome, creative outcomes of the project. Then we will start to have some really in-depth understanding of how creativity develops through collaborative e-learning. And once this knowledge is generated, it can feed forward to course design, telling us how we can design a project in online e-learning that would really increase the level of creativity of our students. So we create a virtuous circle in education. To me, that is the promise of e-learning and big data in combination, not in isolation, okay? So I probably should end here. If you like the monkey business that I present to you today, perhaps we can have a conversation, and maybe we can work together to come up with something interesting. So thank you very much.
Thank you, Professor Chiu. We are honored to have Professor Rob Miller as our next speaker. Professor Miller is a full professor in the MIT Electrical Engineering and Computer Science EECS department and a member of the Computer Science and Artificial Intelligence Laboratory. He earned bachelor's and master's degrees in computer science from MIT in 1995 and PhD from CMU. He has won an ACM Distinguished Dissertation Honorable Mentioned as NSF Career Award and 6 Best Paper Awards in US and USNIX. He has been Program Co-Chair for US 2010, General Chair for US 2012, Associate Editor of ACM Tochi, Associate Director of MIT CSEL, and Education Co-Officer of MIT EECS. He has won 2 department awards for teaching and was named a MacFaker Faculty Fellow for outstanding contributions to MIT undergraduate education. His research interests lie at the intersection of programming and human-computer interaction, including cloud computing, online education, software development tools, and end-user programming. The title of his talk is Online Education with Learner Sourcing. Professor Rob Miller, please.
Thank you. Thank you. It's wonderful to be here. I'm going to talk about some work that my group has been working on over the last couple of years. And the big idea that I hope you take away from what I'm going to say is this notion of learner sourcing, which you should think of as crowdsourcing, where the crowd has been replaced specifically by a large group of learners, which is exactly what we see online. And the domain that we're going to think about learner sourcing is in video learning, is in improving the video content that is delivered as part of many online learning experiences. So here's some examples. On the left, you see recorded video lectures like you might see in edX or Coursera. On the right, on the top, we've got Khan Academy, which was already mentioned this morning. And on the lower right, this is just a cooking video that somebody on the internet has uploaded to YouTube. So there's a very large diversity of learning content that's appearing online. The crowd is creating instructional content as well as using instructional content. And we're thinking about this whole spectrum of information that's out there. So video has really made delivery of learning, delivery of instructional content scale. It's taken what used to be the one-on-one apprenticeship model and turned it into something that can be delivered in a MOOC to millions of people at the same time. The downside is that that's just because we're delivering it in a scalable way doesn't mean that people are actually learning in a scalable way. That traditional sort of direct interaction between a tutor and a student, or even between a lecturer and a group of students, has a lot of advantages. There's high engagement. Because I'm looking at you, you feel like you have to pay attention to me. I can also be aware of whether you're paying attention to me or not. I can look around the room and see how well I'm doing. And if you're falling asleep, I might become more animated. Or I might repeat what I said because you didn't hear it, right? So we get that feedback as an instructor, and we can adapt what we're doing. Even in a lecture hall scale, there's adaptation that can happen. Well, that goes away when we go to video. We've now got this mediator, this video interface between the instructor and the student and the learner. And for the learner, it's a very passive and isolated experience. You're not surrounded by other people who are giving you cues about how you should react or about whether they understand or not. You're just by yourself. And it doesn't adapt to the learner, and it can be very difficult to navigate with these video interfaces because they were really designed for television and movies. The video UI, the UI that we use for watching online learning content, whether it's a lecture or Khan Academy or a cooking video, it's the same UI that was developed for watching DVDs, right? And that's not adapted for learning. So in fact, that's going to be the area that I'm going to focus on because my group does user interface design. So we're thinking about this thing in the middle here and how we can make it work better for both the student and for the instructor. So we want to find out what learners are doing so that instructors can, in a sense, look at that sea of faces and get some feedback about what's happening with their videos. And we want the learner to be able to see more easily what's inside the video, and in particular for the video player interface to be more aware of what's inside the video so that it can present it better. Now, the idea that we're going to use to improve this video interface is crowdsourcing specialized to a crowd of learners. So crowdsourcing is it's an idea that's been around for about 10 years now. And the basic idea of it is that people out on the internet, large group of people, are doing small bits of things that allow us to solve problems that we don't know how to solve completely with artificial intelligence yet. And in return, the crowds might get small amounts of money, so that's what happens on Amazon Mechanical Turk. They might get some fun out of it. That's what happens with games with a purpose. Or they might get some social connection out of it. So Facebook, in a sense, is a large crowdsourcing platform. We're looking at how we use students, or learners in general, to do small things that improve an online course, in particular improve the videos that you get from an online course. And what we want the learners to get in return for the small amounts of work that they've done is a better learning experience themselves. I'll say a little more about that later in my talk. So there've already been examples of this idea. The discussion forums that are really essential to making MOOCs work are a kind of learner sourcing. People are choosing to answer questions that other people are posting. We have also seen peer instruction and peer grading being examples of learner sourcing, where the people in the class are helping to make the class run by teaching other people or by assessing other people's work. So learner sourcing is already happening. I'm going to talk about two variants of it that we've applied to improving videos. One variant is sort of the big data world. So we just watch what learners are doing and don't actually interrupt what they're doing. So we're collecting data about thousands or millions of people that are interacting with our content, and we're using that data to make the experience better. And then the active learner sourcing is where we're actually going to ask particular learners to do particular things that are going to improve the video content. And actually, the act of doing something is going to improve that person's own learning experience, as Dr. Terman said in his lecture a moment ago. So let me say, that's going to be the outline of my talk. I'm going to show you some work we've done on the passive side, where we've taken lecture videos of MOOCs and data from lots of learners who have been watching those videos and used them to improve the video playing interface. And we're going to look also at the active learning side, where now we're taking videos from YouTube that were just uploaded by random people from the internet and added some exercises to them that allow us to improve those videos and make them easier to use. So let me dive into the passive learning side first. And this is work done by my student, CUHK Kim. And so when we look at lecture videos for MOOCs, they tend to be played in an interface that has a play button and a timeline, and that's pretty much it. You don't see what else is going on in this video. They're not really optimized for seeing what's going on, and furthermore, the teacher, the person who has created that video, doesn't have any sense for whether the video is actually working. What are these moments of confusion where maybe I need to explain it better? Right? Where do people get bored and drop off? What are the aha moments? What are the very special parts of the video that maybe we should bring out? So we analyzed clickstream data from 4 different courses in edX, sort of spanning a variety of domains here, but not only STEM but also humanities. And we see a number of patterns in the way people are watching videos. There are people who just watch sequentially, so imagine this is the timeline of the video that we're seeing here. There are other people that watch for a bit and then pause and then keep playing. There are other people who watch and then rewatch parts that maybe they didn't understand or need to understand better. We see people that skip and sort of skim through the video to see what's in it. And we see people who are just jumping around. So all of these behaviors show up, and they represent sort of different parts of the video that might be important or might be interesting. So one way that we can aggregate all of this data is to take the traces of the parts of the video that each particular person has watched and simply add them up. And we end up with, this is basically the number of times that each moment of the video has been watched by someone. I'll show you one general pattern here is that the trend tends to be downward. The first parts of the video are watched much more often than the last parts of the video. But then we also see these peaks that have drawn many people using different strategies into that part of the video. And those are significant peaks where something is going on that we need to understand. And let me give you some examples of what we've learned about some of these peaks. So frequently around these peaks, there is a visual or a topical transition that occurs. So one kind of transition is when the video has made a cut So here it was showing a piece of a Python program that the instructor is describing. And then there is a cut to the instructor's head. And what we see after that cut is a lot of people backing up to be able to keep looking at that program that they hadn't quite understood yet or they need to refer back to in order to capture, right? So one way of thinking about this is that this is where the video editor has maybe made a mistake, or at least has done something that wasn't working for some of our learners, some of our students, in putting that cut in there so soon. Here's another example. So when there's a visual transition just before an interaction peak, that's often a sign that it's a start of new material in this video. And people are coming in here in order to start watching that segment of the video in order to get what was in there or relearn it. What we've done with this data is used it to drive some new user interface features in the video player, right? One way we could use this data is to feed it back to the instructors, and we have done that, but it's expensive to re-record or recut videos. So what we're trying instead is to change the user interface so that the video player will do a better job of making these interaction peaks useful to people. So this is the UI. This part is where the video is playing. There's also a transcript over here on the right, which edX and Coursera and many other MOOC platforms already have. There's a part right here that I will explain in a moment, and a part right here that I'll explain in a moment. So that part on the bottom, this actually shows the raw data of other users, other learners who have been watching this video. It's a profile that shows where the interaction peaks are in this video. So you can see which parts of the video other people found useful or interesting. This is actually derived from an old idea in user interfaces called readware or editware that's similar to finding the parts of a book that are heavily dog-eared or heavily bent because somebody has turned to that part of the book and read it very frequently. So a peek here is like seeing where are the other people in this class paying attention. Maybe I should pay attention to it too. We also use this data to pull out these visual highlights, which essentially capture the key slides, the key moments of that lecture. And we found that they actually correspond very well to where the peaks are. We can also use this to automatically pin a frame after a transition. So if we see many people backing up and going back to a complex slide just before a cut, what the video player will do automatically, it will freeze that frame to the side of the video player while continuing to show the playing video so that users don't have to do that backing up themselves. So these are some of the things that we can do with the big data that we get out of people watching. We've done a lab study of this using about a dozen students, both from MIT and who are taking a course on MITx, in which we gave them LectureScape, which is that UI I just showed you, versus the baseline edX interface, and observed how they behaved, and gave them several tasks that simulated what people need to do with videos, not just watch them, but also go back and look for information, and go back and find what they need to solve a problem, or go back and summarize for themselves as if they're preparing for an exam what it was that was in the video. So those are the tasks they had to do. Here's just a brief summary of the results that we found. So LectureScape enabled them to do a lot more nonlinear navigation through the video. They were using it much more in a goal-directed way rather than having to rewatch long stretches of the video. And they were exploiting all of these navigation options that we provided to them. The roller coaster that told them where the highlights were, the highlighted frames, and the pinning. And one of our learners reported that they just felt it gave them more options and personalized the strategy that they were using to navigate around. They also found when we asked them for themselves, without showing them the data, what they thought the points of importance and confusion were. Confusion correlated pretty well with the points that were coming out of the interaction peaks. importance also found some of them as well. And I think this is really important, that when they were using the Lecturescape timeline, they felt like they were there with other people. It wasn't as isolated as an experience as it would otherwise be. Now, we're in the process now of integrating this into the edX platform so that we can deploy it at a larger scale and see how it behaves with a whole classroom full of students. So that's the first part that I wanted to show you, how we can use learners' data without actually asking the learners to do something specific. For active learner sourcing, we're going to give learners a specific task to do, a little bit of micro work. And the context in which this is going to happen is in how-to videos. So YouTube is full of millions of informally amateur-produced videos about how to do things, how to create effects in Photoshop, how to cook, how to do makeup, how to fix things around your house. The challenge with these videos is that the YouTube interface is not really designed for learning. It's just a video player. It's hard to tell what's actually going on in these videos. You've got a short summary and you've got a title, but you don't really know what's inside the video. And it's hard to go to specific parts that you might be interested in. In fact, these how-to videos, they're very structured, right? It's a sequence of steps that the demonstrator is going through. So for a video about how to make a cake, there are steps to the cake recipe. First you do this, first you do that, then you do that. And even above that, there are sub-goals of the whole goal of making a cake. And in fact, there's previous work that has shown that people transfer their knowledge much better from one demonstration to another demonstration, to actually making a different cake yourself. If they're told what these sub-goals are, if they're given the higher level reasons for each of these individual groups of steps, that to make a cake, first thing you do is get all the dry ingredients and mix them together. And then the second thing you do is separately you combine the wet ingredients. That kind of sub-goal information is very powerful for learning and for transfer. So what we've done is created a video player that allows us to display these sub-goals and these steps on the left side while you have the video over here. And this acts as a navigation interface as well as basically a summary interface of what's inside the video. Now the challenge, since we've got millions and millions of videos on YouTube that don't have any of this metadata, they don't have these steps and these sub-goals. Where do we get those steps and sub-goals? How are we going to get them out of the videos? The way that we're going to do it is by having the people watching the videos give them to us. And this is the learner sourcing idea here, that we're going to get the crowd of people that are doing the learning to do small amounts of work that will improve the video, that will give us this metadata. Essentially, every minute of video that you watch, you'll get a little question. And that question will first be something like, give us the step or give us the sub-goal of the part of the video that you just watched. And it'll be a text box, and you'll type it in. And once we've collected some proposed steps and sub-goals from some learners, then the next learners to get to that point in the video will see those as a little multiple choice question here. Which of these sub-goals or steps proposed by a previous learner is the best description of what you just saw? Choose one. And then there's a third step. Once we've sort of isolated a winner, a most popular choice of how to describe that minute or so of video, then we have a final proofreading step in which other people will say, yes, that's right, no, that's wrong, or here, let me propose another way of saying it. Right? So that workflow, and crowdsourcing often has workflows of little steps like this. That workflow is now being done by the learners that are actually watching this video. So we've done a deployment of this. We deployed a website that had a sample of YouTube videos on specific topics, on web programming and on statistics, and we advertised it in various ways, social networks and Google Ads, and attracted a few thousand visitors, of whom about half of the people who came actually participated in the sense that they answered some of these learner sourcing questions. So this already is interesting, that 50% of people on the web who are just watching a how-to video are actually willing to answer these kinds of questions, right? Which is one of the questions about this kind of work. And we've gotten about 1,000 goals, about 1,000 answers through these processes, to get them through these workflows. So these people have actually done some work, even though they're not being paid to do it. We went back and, with their permission, identified some of these people and interviewed them to find out what they found useful about this process. One of the things was that they said it helped them pay attention to the video. And Dr. Terman did mention this in his talk as well, that doing something active while you are learning really does help you process it better and learn it better. And this is a small bit of active work that does that. Seeing the choices that other people had made helped the learner think that they were on the same wavelength, and also made it feel like it was a more social learning process, that there were other people here with in the video with them. We also asked some of the video creators how they felt about this, and having these pop-up questions, they liked it because it meant that the viewers were actually paying attention to their video. So they thought it was a useful improvement. So I hope I've given you a sense of what we can do with the crowd of people that are learning from our materials, and that there are kind of two approaches we can take here. One is the big data approach, of just watching what they're doing, but there's also an active approach where we actually ask them to do some exercises that improve the video. And I want to thank the sponsors, including NSF Quantum Computer and Google, and we also had some great collaborations with edX. Thank you very much.
Welcome back again after the coffee break. We will be starting the third section. The next section will be presented by Professor Ian King, Associate Dean of Education of Faculty of Engineering, CUHK. Professor King is professor of the Department of Computer Science and Engineering. He is also the director of Rich Media and Big Data Key Laboratory at the Shenzhen Research Institute. His research interests include machine learning, social computing, big data, data mining, and multimedia information processing. Recently, Professor King has been an evangelist in the use of education technologies in e-learning for the betterment of teaching and learning. The title of his talk is Big Education on KEEP, Knowledge and Education Exchange Platform. Professor King, please.
Thank you. Can you guys hear me? Yeah, it's okay. I kind of like to walk around. I'm not going to hide behind the podium. So first, I'd like to thank Helen and the organizing committee. I think I'm one of them. So for inviting me to this talk. And I really think that this kind of workshop is fantastic in terms of promoting and encouraging people to think about e-learning and big data together. So my talk today is Big Education on KEEP. And I'd like to just first present to you the state of our education right now. If you are the teacher right here, can you see that? This is a teacher. And these are the students right here. And this is in Chinese, so I'm going to just do the English one. It says our education system. Everybody is a genius, but if you judge a fish by its ability to climb a tree, he will live his whole life believing that it is stupid. Okay, and I believe that the new wave of big education will abolish this. Okay, we're going to do personalized learning path. We can do a lot more. But anyway, this will serve as a good point to start. The words of wisdom, and I know there's a lot of educators here, so I hope that I'm not going to offend anybody, but I think that good university focus on counting the number of publications, right? And then better university focus on citation number impact factors. So what do you think the best university will focus on? Education. Yes, that's right. So that's why we're here. Okay, so I've been asked, right? So my title is Big Education on KEEP. So the question is, what is big education? So I'm going to give you a very simple explanation. Big education is a man meets a woman, or a boy meets a girl, right? And this guy is Mr. Big Data, and then she is a Miss Education. So you put these two together, I call it the big education, okay? So, and you may know this too. We're bombarded every day by all sorts of information and data. And this is what we call it big data, right? Our life is big life on big data. Now, you're very familiar with this slides next, okay? I don't need to describe this. You guys all know the 4 V for big data. But did you know that there's also 4 Vs for education as well? Big education as well? Let me explain to you, right? First of all, the volume, okay? Nowadays, we have so many types of teaching stuff. For example, we have Coursera, edX, Udacity, and Khan's Academy. The available of teaching material online, okay, is overwhelming. That's volume right there, okay? Secondly, velocity. I think that we all really fall into this. This is how do we actually face the change, the rapid change, the pace of change that happens in education, right? The technologies that we use, the pedagogical approaches that we adopt, and all that stuff, okay? So this is really the velocity at which things are changing in education, in big education. That's velocity. The third one is variety. What is variety? Well, there are actually many different ways that we acquire our knowledge these days. We don't do it in the classroom, but we could do it online. We could do it on our phone. And eventually, I'm going to show you something, maybe it's on our watch. We could actually learn something. So this is the variety of sources that we could get or obtain education and maybe even do teaching on, okay? So what do you think the veracity would be? What is veracity? Veracity is the uncertainty inside our data. And what would that be in big education? Now, in here, I'd like to show this because I'm actually the creator of Very Guy. Because because of internet, right? People actually make copies, could copy materials on the internet very easily. That makes your education kind of uncertain. How did you know that actually you did the work in big education? What could it be someone else, right? So I show this Very Guy right here because we have created this system, plagiarism detection system, to ensure that we uphold academic quality and academic honesty. And that's what I call the veracity in big education. So how do we actually find the truth about our education? So these are the 4 things. And my favorite thing is that out of all this, right, there is a value issue, right? We have all these things. We have all these new MOOC courses. We have all these ways to learn on a mobile phone. But really, is there value in all these things that we do? And I believe that it is. There is the value that we have. Okay, so, and I want to also extend this too. This is really a education timeline. And most of the stuff that I'll be talking about perhaps is focused on here. But I like to remove that myopic vision, and I like to suggest that big education is really about lifelong learning. Okay, big education is not only applicable to the university, but also applicable to professional certificates, lifelong learning, and all the way extend out to even kindergarten. How do we actually track their performance? How do we encourage them learning, creativity, and so on and so forth? And I think that's really important. Okay, so teachers, this is a slide I like to show because that looks like me, okay? Because for me, in the world of big data or big education, it seems like I need to learn all sorts of skills, new technologies, and new ways to do teaching and learning and all that. Although I'm a teacher, but at the same time, I'm also a learner, right? So I feel like I'm this person right here. I need at least 4 arms to do all the tasks that I have. So the question is, shall we actually all become Superman and Superwoman and super kids, okay? I think not. I think really the task of our modern educator is not to cut down jungles, but to irrigate deserts. And that's what the purpose of me being here. I hope this is fun, right? Is this fun? Yes, okay, I hope so. Okay, so I'm going to just give you a few things about trends in big education before I go into KEEP. Okay, so there's a couple of things I've been observing the last few years, and I think it's worth taking them out and kind of examine that. And first, I'd like to actually show you the online learning landscape, okay, because that is about big education. And you can see that online open universities, MOOC sites, platforms, search reviews. This is really all the companies. So now we have really an ecosystem now. We have a huge ecosystem that and has a really nice landscape and on various aspects of e-learning and on big education. But I'm going to show you the next couple of things. I'm going to use these three things criteria: collaboration, cost effectiveness, and customization as a characteristic of the things that I'm going to share with you. Okay, so collaboration, cost effectiveness, and customization. The first thing I think that the trend in big education is that multimodal learning. So students, in fact, acquire knowledge from different sources now. It is not good enough to just put your things on your website, but you might have to saturate it on YouTube, on Coursera, on different things. Here is an example. Harvard has presence on their website, on YouTube, on Class Central, on edX, on iTunes, and so on and so forth. So they saturate the whole social media scenes and all the potential channels because people, in fact, acquire knowledge differently, and we don't want to just have one way and one way of doing things. We want to be able to actually have multiple ways and multiple ways for them to obtain knowledge. So this is one trend that we've been seeing. Another thing I've seen in the last really a few years is this. We, as an educator, we start with a course. We have pull material together. We create a course. And then we make that course online. We put that thing electronically. We put it on our website, on our Dropbox or whatever. We make that online. Then we made that open to the university and maybe other departments and so on and so forth. And the last frontier really is to make that massive open online course. And what does that say? It's the acronym is for MOOC, right? So yes, MOOC is one of the things that is a trend that we're seeing. Next, I want to say something about this. In fact, I'm a proponent to this thing because it's a small private course with degree, because this is what university will exist for, is the face-to-face interaction, is the time that you can spend with your teacher and with the student. That really matters. MOOC is a little bit, how should I say, impersonal, right? It could be, because the engagement and the interaction is not there. But there are successful cases, for example, small private online courses with degree. AT&T joined with Georgia Tech and Udacity, for example, will offer tailor-made professional courses, okay? And they could get degrees from this. And I think that is the coming trend in the future. Okay, another thing, I don't need to talk too much, is like preaching to the choir, is a flipped classroom, but more and more people are doing this. We're having better technology and better pedagogy on how do you flip a classroom, how do you make the flipped classroom interesting, and so on and so forth. So this is another trend in e-learning. So this is the flipped classroom. Another thing is we are also doing, in fact, in Chinese U, is to convert a lot of material that we have into micro modules. Okay, so what we're trying to do is to break down a big concept into smaller pieces, right? Each video could be 5 to 10 minutes long, and actually, I'm going to show you what our implementation of this micro-learning looks like with links and so on and so forth. This will facilitate learning because we found out, younger generation, they have the attention span of a gnat, right? So that's like a fraction of a second. So 5 minutes to 6 minute video is probably the most optimum thing that they could actually do. So, but on the other hand, the micro module can also facilitate personalized learning path. Because once you have broken the component down, you could actually create different paths for different people, depending on the person's preference and the person's needs, and so on and so forth. So that's actually very, very important. Next thing, so that is related to what I would talk about. The micro moduling is really also is related to the personalized learning right here. So in here, what you could do, one could do is to create their learning path. Okay, so this is quite important, but we need that micro module first before we could actually do this well. Okay, so another thing that we also found out is this, right? The outcome, the performance actually increased when you could do activity inside the classroom. And this is the reason give rise to also flipped classroom. So you do the homework inside the class. You do activities. So active learning is one of the things that we will highly recommend. Now, it's good for engineers because like you teach a programming class. You don't just talk about programming. You actually do programming inside class. I teach data structure. We want to do algorithms. So we want to do the algorithm right there and then. You get immediate feedback. You know whether it's right, what is wrong, and so on and so forth. So active learning is also another aspect. Lastly, but not least, is something that that cannot be done perhaps before, but now we could do this on a large scale. Is peer learning, right? We had classes here that connected to a massive amount of international students. So when we had Occupy Central, for example, I mean, people were asking, how do you guys feel? What is the situation there? So other people from other parts of the world will be able to learn something that they were not able to do before. So peer learning and peer assessment and so on and so forth is also a very, very important component in this big education thing, okay? So, and how much time do I have? 10 minutes, perhaps? Okay, so with that in mind, I'd like to just use the next few minutes to share with you KEEP, okay? KEEP it stands for Knowledge and Education Exchange Platform. And what it is simply a multi-year cross-institutional project with all the institutions in Hong Kong. So we really say that this KEEP project represents all Hong Kong's institutions, okay? KEEP is basically a big data learning analytic platform that will allow teachers and students to experiment with different type of blended learning. We also serve as a creative online learning gateway for educators, and we encourage and promote flexible and active learning on the KEEP platform. KEEP is a knowledge aggregator, I'm going to show you why, and a technology integrator. So with that in mind, I want to share your vision. We, KEEP, would like to empower people by providing and promoting the best education resources in order to facilitate collaboration and innovation for teaching and learning through knowledge aggregation and technology integration. I know that's pretty long, right? I made that up. I did. It's a long, but I think that you describe precisely what we want to do, okay? Very precisely of what we want to do. Our mission is to organize education resources as a single centralized point, so you don't have to go to different places to search for Coursera or edX or whatever. You just come to here and you will get that. We also want to offer a recommended personalized learning path and provide insightful learning analytics. And we want to deliver the best practice on courses, on material, on product, on service, on software, on our hardware related to teaching. That's what we want to do. And lastly, we want to build a platform that will facilitate the innovation development of education software. That's what we want to do. So 4 things right here. I'm going to, so this is UGC funded. All 8 of these are in the project. And here is what we want to do is we want to use Amazon's web services. We talked to Google already. I'm also talking to Microsoft and see what they could help us in terms of the cloud and services, and also their interest in e-learning as well. And these are some of the people we already have a very close tie with. For example, I just came back from a Coursera conference last week, and we've been talking to edX and so on and so forth. Okay, so with that in mind, I'd like to just briefly show you. This is probably the most technical thing you will see. Okay, but this is a 4 components that we have. First is the search engine right here, content. We will crawl our local website, education-related material, and put that on our search engine. Second is we tie with universities' database system so that we will know who's logging in and also track their behavior and so on and so forth. Third is that we interface with Coursera, with edX, with Udacity, and Moodles, and so on and so forth. So we will run these platforms on our system. Okay, so when you access these other learning management system, we will actually get a record. That's at least our hope. And the last thing here is that we encourage innovative educational software to be developed on key platform. We will provide APIs so that we could collect also analytic information when you develop that. Okay, so with that, I'm going to just show you a couple of apps. The first thing is Keep Search. You can see that is almost like a Google search, but it's better. Better in the sense that, it only will provide you with educational resources. It will not give you all sorts of junk, right? And we actually cluster the result in such a way that you could see what are the cluster inside that search, okay? And then we can actually direct you to edX things or Coursera material and so on and so forth. So that's our search engine. We're going to do more, hopefully, in the future. Okay. The Keep course right here is really our course that you could get on to Keep and start a course using one of our farm's tools. So we have Moodle, for example. We have Open Canvas. We have Open edX. And then we also run Google's Course Builder. Okay, so all these things are available on Keep. You could create a course with that on Keep right now. Okay. The Keep catalog is a way that we want to showcase the best practice in terms of software, hardware, and services. So we will provide you with all these. You know, how do you actually use YouTube inside an education environment? Did you know you could use YouTube very effectively? I know it doesn't happen in China. Okay. But you could do YouTube very nicely, right? How do you use LinkedIn? How do you use all these different products that could facilitate big education? Okay, so we will have this available for you with reviews, with recommendations, and so on and so forth. Oh, I want to just say something about KeyPoll. KeyPoll is a polling software that we have developed. It's on desktop, it's on the mobile phone, and in fact, I just got this this week that we're able to put it on the Apple Watch. Okay, so I'm going to show you that a little bit later. What this is basically, it's a polling system, a survey system that will help to improve student engagement, as well as the teacher will be able to get a quick assessment of their teaching quality. For example, do you know this particular topic? Yes or no. We'll give you multiple choices that you can actually do very quickly. So with that, I'm going to just show you this. Let me see. Yeah. So right here is this. This is actually a poll. I asked the question, when would you like to take the programming midterm in my data structure class? Is it Thursday? Is it Thursday, March 19, March 26, or April, whatever? Here is the analytic that this is the voting has been done. 20 people think this date, 22 people think this date, 25 people would prefer this date, right? So this is just a question. Here is actually a simulated Apple Watch. Okay, this is from the Apple simulator. And we are able to push this, and this is very special. We're not pushing to everyone. We're actually working with Apple iBeacon. So when a teacher is sending out this question, it will only send to those people they share the same iBeacon ID. Okay, so I'm not sending out this to everybody in the world. I'm actually doing a location-based service using this. And furthermore, you could do this on the watch. So in one day in the class, there's no more clickers. You don't need to use your phone. You could just look at your watch and tell the teacher whether you like him or not, okay? So vote for me, right? Vote for me, okay. So this is something that we just did a few days ago. So I'm so excited to show you this. Okay, and next thing that I want to share with you is what we call a Keypedia. What is Keypedia? The way I describe it is YouTube meets Wikipedia meets Pinterest. Okay, if you think about that, this is micromoduling YouTube with Wikipedia information. So there is a text that surrounds that particular video. So it's not just a video, 6-minute video, but it will be the prerequisite, the reading material, the quizzes, and so on and so forth associated with that. Right? And then done in a way that is like a Pinterest, that is really interesting. So you combine these three, you have what we call a Keypedia right here. And each one of this is a short video, and then with a related linked data, like a Wikipedia, that could go to different parts of this huge universe right here. Okay, Keypository is something that I think maybe is good for the student. I thought it was good for the student and also for the teacher. This is really, we are trying to create a crowdsourced question base, okay, for teachers and students. You know, we teachers always afraid, oh, we don't want to reveal the question to the students, but that's the way they learn. So why not just give it out to them, right? So if we have a crowdsourced thing right here, we could actually put questions into this repository. I could create a survey, like the Apple Watch survey very quickly, or I could create quizzes or examinations based on the repository. Student will be able to use this repository to play games, okay, to answer questions, and then go to the next question, and so on and so forth, because there are different levels of questions that we could make this interactive, and so on and so forth. So this is the Keypository we're building right now, okay, for that. Lastly, the key apps. So these are some of the apps, and Helen, you're gonna give me an app too, right? On a speech assessment thing. But we have Very Guide app and Easy Scripter app that is sitting on top of on the Key platform, so that they will be collecting also analytic information and send this back to the respective teachers and the university as well. Okay, so this is what we plan to do. There's some work in progress. I said before, learning and education analytics is the next phase. We're going to include lots of game stuff in there. So how do we gamify? How do we make learning interesting, right? So we have the repository here. So we could play a game like a Risk. So when you solve a problem, you increase your territory. When you create an interesting problem, you defend your territory. So you could play this game with this Keypository, okay? And that's what we want to build. We want to do more on social collaborative things so that peer learning and peer assessment can be done very easily and efficiently and precisely. Because right now it is, not there yet. We also want to go into the mobile and the wearable education technologies, like what we talk about using watch and other things. Okay, so these are some of the up and coming. My background is in machine learning and natural language processing and information retrieval. So we hope to actually include, for example, text semantic analysis, sentiment analysis, question and answer, a better question and answer system inside the Key. We also want to do recommendation for personalized learning path, career planning, and so on and so forth, okay? And knowledge map, don't worry about this. And then powerful search engine, we want to do this. We want to be able to actually search for notes, equations, videos, and so on and so forth, okay? And algorithm technology, this is where I live. This is my universe. So it's machine learning, data analytic, social computing, web intelligence, and multimedia information processing. So we hope to really use what we have done in the research and apply this in education in a big way, okay? So that's why they call it a big data on Key, okay? So I hope that you guys will get involved. So feel free to contact me. And last but not least, I end with this. It says this, do you know what clouds are made out of? You say, sure, music files, right? But I hope one day the question will be, do you know what Keep Education Cloud is made out of? And then you'll answer, sure, a fantastic search engine, organized education resources, insightful analytics, and innovative apps, and a lot more, okay? So I end with that, and I thank the team here and all the collaborator, co-I, and advisor, and my co-PI here. I thank them for this wonderful project that I'm able to actually be involved with. And that's it. That's all I have. Thank you very much.
Thank you, Professor King. We are honored to have Professor Victor Xu, Delta Electronics Professor of Electrical Engineering and Computer Science, MIT CSEL, as our last speaker. Professor Xu has spent more than 3 decades at MIT. He studied and codified the acoustic magnification of speech sounds in American English and the subsequent application of this knowledge in the development of spoken dialogue interface to make human-computer interactions easier and more natural. After a 10-year hiatus serving various stewardship positions at MIT, he has returned to teaching and research in 2011. His current research interests are in the area of applying human language technologies to enable easy access of structured and unstructured information from the web, especially in online education. Professor Xu is a fellow of the Acoustical Society of America and a fellow of the International Speech Communication Association. He is also a member of the U.S. National Academy of Engineering and a commendation of the Commandeer Seneca in Taiwan. He received the Okawa Prize in 2012 and the IEEE James L. Flanagan Speech and Audio Processing Award in 2013. The title of his talk is Using Human Language Technology to Improve MOOC Learning. Professor Xu, please. Thank you.
It's really a pleasure to be here. For those of you who did not know, I used to be a student at CUHK. Actually, it was before CUHK, called Sun Ah. And my best friend during that day was Professor Li Tianming. We were not very good students, but we had a lot of fun. Anyway, like Helen, I spent most of my professional life on the development of human language technologies. Human language technology means enabling machine to recognize speech or synthesize speech or understand natural language and generate natural language or worry about modeling discourse and dialogue, these areas. So it's not a surprise, perhaps, that after being away for 10 years, helped to run the lab, I returned after the sabbatical in Asia to go back to human language, but trying to apply that to the problem of how to improve MOOC learning. I think it's really interesting. It's hard to imagine that it has been less than 4 years since the first course in MOOC was offered. In 3.5 years' time, we have really done a lot in this area. However, when you think about e-learning, I think we're doing a lot of e, but are we really doing a lot in learning? So I think this workshop is particularly appropriate at this time. So it's a bit like 战国时代. Okay, lots of nations are trying to fight out market shares. But fundamentally, I think we need to understand how a new way of interacting with students is going to help us improve learning. And I think this is what we're here to talk about. So I should say that the work is done with my student and Dr. Hongyi Li, who spent a year at MIT, and now he's a professor at the National Taiwan University, working in this area. So So human language technology and MOOC, these two things are related because so much of our courseware, human language, is a part of education, whether it's going to be textbook and slides or lectures or discussion, something to do with natural language. But what MOOC offers are two big challenges. The first one, in my mind, is heterogeneity. You know very little about the background of the people, and that background can be extremely diverse. You have high school students, you have retirees trying to do something, or someone in mid-career trying to change from one profession to another. Their learning style is different, their language is different, Chinese versus Indian versus European. And also, the preparedness is different. So it's very heterogeneous. If you're coming to CUHK, you're teaching a class here, you have a pretty good idea about the background of your students. And part of the challenge is how to deal with this diverse background for the students. And the second thing has to do with scale. You have heard a number of people talk about that. And you basically cannot have a one-size-fits-all type of way of learning. This is a direct consequence of the heterogeneity of our student body. What we need to do is to worry about mass customization, okay? It almost sounds like an oxymoron, but it is really true. You want to be able to customize for individual learners, and that's what we're trying to do. Now, human language technologies, I believe, could help. It could help us process and manage a large amount of content. You can do that. You can develop speech-based interfaces rather than typing or clicking. Maybe it will be easier for you to have a search engine that you can interact with using human language. But you really need to worry about how to develop general and scalable solution whenever it is possible. All right. So what are we talking about in terms of human language technologies application to the problem of MOOC? Many, many different things you can do. First of all, if the lecture is given in voice, what you really want to do is to be able to transcribe that. Currently, it is done by humans because if a course has 100,000 students, for example, you can afford to create a high-class transcription by asking people to type it in. But of course, there will be a delay between the time that you offer the course and when you have the transcription. You can do some machine translation, turn it into multiple different languages. You can do that, but it's a long-term research problem. Translation technology has advanced significantly over the last decade. However, it's not good enough. And if you want to use machine translation of the material, it better be as perfect as you can get. And you can worry about problems in language technology to do user identification and authentication. If you're going to offer a grade or a certificate, you certainly want to know that the person taking the exam is exactly the same as the person who registered to take the course, right? And then there is a very large area in terms of information management, how to characterize the information. If you have a discussion forum with thousands and thousands of entries, how can you tell? Put them into categories. These having to do with confusions on lecture 3, slide 17, for example. Or you want to say things that has something to do with the examination schedule, administrative issues. You want to be able to do that. And an area that I'm going to spend some time on is this issue of linking. How can you take different kinds of courseware and you try to combine them together, link together in such a way you can have easy access, for example. And then you have other problems in information management having to do with summarization. How can you say, give me a 5-minute summary of that lecture? Or maybe a 15-minute summary to be able to customize it to people's needs. A sort of a computer-generated Cliff Notes, if you will. And finally, you want to worry about search. You want to make it easy for people to find the information that they need. Now, we are at CCEL, we're mostly spending time on these categories. So today, I want to show you some of the work that we are doing in this area. Now, before I move on to that area, I just want to reinforce something that you have heard a number of times today, but I want to do it with some data, okay? And the issue is that online and residential courses are different in many aspects. Now, Helen finished this morning's talk with a slide that shows there is residential education, there's online education. People who are doing residential education, like most of us, are a little apprehensive about that, right? Are we going to, if we pursue online education, are we going to basically work ourselves out of a job? But I think it's an interesting problem, and the way I would prefer to think about it is the same way that Helen is thinking about it, that at the moment, the flow of information and technology is one way. What we're trying to do is to say, okay, here are the courses that you're teaching on campus, and how can that be made into online courses? But in the end, the combination of e-learning and big data is going to inform us of the ways that it will benefit residential education. And you have seen some examples of that. So I want to just show you a couple of slides, some comparisons. Now, we've been looking at between 25 and 30 courses being offered on MIT-X and also taught on campus. So the comparison is really nice if you have this many courses. So in particular, I want to focus on one course, which is Introduction to Computer Science. And people like to say this is a course about Python. And the interesting thing is that that course has been offered 4 times online. And we have data for 3 times on MIT campus. Furthermore, that's pretty much taught by the same professor. So we can actually compare these 2 things and try to understand. You know, we neutralize a lot of the variables. So multiple offerings of the same course at MIT and on edX. And then what we're trying to do is to compare those 2 courses in terms of many different dimensions. The class size, how many people actually drop out of the class, and the manner of interaction, the role that teachers play versus the roles that the peers play. And we find some interesting comparisons. Here's an example. On the left-hand side, we're talking about measurements on online versions of the same course and residential version of the course over here. Each one of these, this is one offering. This is the course called 600. It's in the fall term of 2012, spring term of 2013, et cetera, et cetera. There are 4 offerings. Am I making myself clear? Okay. Now, here we have 3 offerings of the same course on campus. So you can look at this and you see, for example, the enrollment. You can see red is the total number of enrollments. That's measured in terms of tens of thousands of students. Whereas on campus, you're looking at 200 or 300 students, and this particular one is a high, the last time it was offered. If you look at the green one, that says how many people who actually passed the course, they were certified. You will see that on campus, the number of people who starts and the one who finishes are more or less the same. Of course, there are people who are dropping off, but not too much. Whereas if you look over here, compare the red with the green, you see a dramatic difference in terms of dropout rate, right? Another example, I mean, I'm just trying to make a few points here, is that if you were to look at this problem of threads, that is in the discussion forum, how many different postings of the thread exist? Then you will see that of these threads, the orange one that you have, how many of those were answered by the teaching staff, and how many of those were answered by your peers, your students, okay? On campus, you see, by far, a lot more questions were answered by the teaching staff, the purple. And here, so few were answered by the teaching staff, you can't even see it, okay, on this scale. Most of the questions were answered by your peers. So in fact, the interaction is very different. So it's not the case we can just graph the way we interact on campus and move it on to online, and in fact, these things are very different. You might ask, why is it that we have so many people dropping out? If you look at the marketing data, it says hundreds of thousands, millions of thousands of students have enrolled in a course. But if you were to look at it, looking at the data, honestly, this is the data provided by Professor John CUHK, who is the instructor for that Python course. And if you look at it, you will see that, in fact, this is the distribution. This is plotting how much time a person spent in the course, and this is a histogram, okay? So what happened is that this is actually the distribution of the students who finished the course, all right, and the amount of time they spent. And over here, the overwhelming, the gray ones are the ones who are, for whatever reason, started the course but didn't finish. Now you say, why didn't they do that? Well, maybe in the very beginning, somebody who spends a few minutes, maybe they're just shopping. They get into the course, take a look, and say, I don't want it, okay? And there are other ones who begin to spend some time, and eventually you see people using tens of hours, maybe here. This happens to be the piece that at least I am interested in. I want to say, if there is a way, maybe that's because they're not getting enough help. Maybe because their background is not sufficient. So what we want to do is to figure out ways to actually take some of these and move them over to the other side, as Chris has mentioned earlier, the distribution, okay? All right, so I'm going to spend the remaining time talk to you about a couple of things that we're doing in the area of linking. And this is the work done by one of my students, Daniel Lee. And the idea is to figure out ways of linking the material together. So what we are trying to do is to say the following, okay? We have all kinds of things, lectures and textbook and slides and all those things. Each one can serve, we believe, a reinforcing role. So if you can take all that information and try to link them together, so when you're talking about a given topic, you can link the appropriate segments of the textbook and the discussion forum, the slides and the videos together. We thought this might be a good way of helping people, okay? So what we want to do is to link those things together and create sort of an adaptive learning environment for students to navigate freely. So our hypothesis is the following, okay? It says if you can organize the courseware in a way that is easy for people to navigate and look for things, then perhaps it's going to improve learning. So today, the way we do it, the unlinked way, whether it's, for example, the red one might be the video of the lectures, this one might be the problem set, still other ones may be the textbook. They are basically organized as monolithic, independent pieces. And what we want to do is to move into this area in which, in fact, they are linked. For this particular topic in the lecture, the appropriate other kinds of courseware, sometimes you have more choices and other times you have less, are linked together. The hypothesis is that if we do this, it's going to improve learning. And to put it concretely, what we're trying to do is to build two types of interfaces. In one case, the video, the books, and other things are done independently, presented to the user independently. And in another case, things that are related to are linked together. So at the same time, they are at your disposal. You can find the information and presumably learn more. Now, learning is a very hard thing to measure. And what we're trying to do is to think about sort of derivative, the properties of learning. And what we would like to do is to say, if we present interface 1, unlinked, compare it to the linked method, we want to measure how well people can look for information, for example, when they're doing a problem set, And how well can they recall the information, the concept retention? These are some of the problems that we're asking ourselves, okay? So could it really help? And what we're trying to do is to conduct a crowdsourcing experiment. You have heard Rob Miller talk about that, so I won't elaborate. So what we're trying to do is to take a course. In this particular case, we look at a statistics course from UC Berkeley. And it has videos, it has slides, it has textbooks, and this kind of thing. And what we're trying to do is to use the Amazon Mechanical Turk, the micro task workers, to be the subjects. And they have varying backgrounds. Some people have college degrees, some people don't have college degree. Some people have taken MOOC before, and some other people have not. And some have taken statistics before, and some have not. Okay? So we were doing in an experiment. It says, well, if we can link it, would it make any difference to these subjects? And the ground truth is actually done by human experts that link them together. But since then, we have created automatic techniques to link these things together. At the moment, we want to know the best possible consequences. And we measure information search, how fast and how accurately can you look for information. So you say, doing a homework problem, you need to know about regression in statistics. How fast can you find the information? And then concept retention, you say, wow, this segment, please summarize it. And we try to measure how many things that we taught you that you can actually recall, for example. Again, the whole bunch of things that we talk about, I just want to pick one to show you. And so here's one that has to do with information search. You ask the person to retrieve a piece of information after they have taken the course. And here is an example. Let me explain this plot for you. Remember, I have two different interfaces. One is unlinked, all right? And here is linked interface, and I'm asking people to retrieve the information. The idea is if linking really helps, it's going to be faster, right? So I take the amount of time that you will use to look for unlinked, subtract the time that you do to solve the problem by the linked interface, and if that number is positive, it provides indication that in fact it's good, all right? So overall, we found that in the tasks that we provide to people, they do it maybe 40 to 45 seconds faster on the average across all the users. Now here's what's interesting. We have these three categories, people with some college degree and some not. And so what we have is differences between these two, and we can measure sort of the statistical significance of that. I think the check mark might have been in the wrong place. No? Yeah. This is people who, with the college degree already, this is the more novice part of the population. People who never taken a MOOC course before. And the significance is statistically, the results is statistically significant. So what it appears to be the case is that linking will improve the speed in all cases. And I haven't shown you the accuracy. It turns out the accuracy in both conditions are about the same. So it gives some evidence of the fact that if you can link the data together, and a number of speakers before me have talked about that as well, that it would help the novice users. So those people, remember I said we want to move it towards certification. They want to complete the course. We want them to succeed, and I think linking might be one of the answers, all right? So as I mentioned to you before, since then we have done some automatic means of taking the course material and try to link it together, and we have some very good results. And the improvement, the most important thing is you didn't sacrifice accuracy, all right? Okay, so let me change the topic into a different kind of linking. And this has to do with linking courses from different places. Let's say in edX, You can have a course on machine learning taught at Berkeley. You have a course on machine learning taught at Columbia University. And some, maybe one lecturer will explain things better than the other lecturer, for example. So what we want to do is to be able to say, take a bunch of courses that's coming in, and you want to link the courses and find out across different courses what, say, you want to learn something, a concept like regression. You want to see how this teacher will teach and the other teacher will teach it, so you can link the material that way. And also, you can actually, based on this, be able to figure out what are some of the prerequisites. If I'm confused, I want to know how far back I have to go to pick up the necessary background information. If I'm bored because I already learned this information, how I want to move on to the next level of more advanced material. So this thing is done in about half a dozen steps, and I will quickly go through it with you, okay? The first is to gather the data. You take all the course material across not only different universities, but different platforms. In fact, this thing I will show you later, we take a Coursera courses and edX courses, and we can deal with that simultaneously. Collect the video clips and collect the MOOC, across different MOOC, and that's the first step. The second step is we try to extract automatically the key terms in each one of those lecture vignettes, if you will. And based on the audio transcription and different kinds of things, for example, one of the things we do is to tag automatically the parts of speech for these cases. And then we pick out the nouns and noun phrases and consider them to be candidates, all right? And then we are going to filter by some lexical statistics. For example, in our case, we were using TF-IDF, term frequency, inverse document frequency type of measurement. Once that is done, we get a bunch of noun, phrases, for example, for a computational biology course. The third step is you begin to extract the relationship. And what you want to do is to be able to form the relationship based on these kind of concepts. So if the transcript said the DNA encodes RNA, it is the material of inheritance. So this pronounal inference, you want to change it to co-reference and turn it into a DNA. Okay? Just converting the pronoun into its reference. Then you do some syntactic parsing of these sentences, come out with the parsing of the sentence DNA is the material of inheritance, for example. Then what you want to do is to say, I want to extract the relationship between these entities. And so what you can do is to say these two things, DNA and inheritance, are related in some way. And the way we want to find that relationship is using a statistical model. In this particular case, for those who are interested, it's called open information extraction. Okay? And once you do that, then you can say that's the relationship between two entities, and we can figure out the relationship. All right? The fourth step is to create something we call a knowledge graph. Once you have these entities there, and you can figure out that DNA and inheritance, one is the material for inheritance, and then for DNA, all these links you generate automatically, creating something we call a knowledge graph, okay? 2 more steps. Then what you want to do is learn what are the prerequisite concepts for a given entity. What does that mean? Sometimes if one person say, I am lost, we're going to say, oh, let's move on, review some of the material so that you can move forward. So the way we do that is to actually try to figure out the relationship. And here, let's use these 2 examples, okay? So what you're trying to do is to say, all right, DNA happens to be first introduced in lecture 3, whereas the idea of inheritance was first introduced in lecture 1. And therefore, 1 is the background material from lecture 1 for 3. So inheritance is the prerequisite. Similarly, if you were to look at DNA and RNA, this is first done in lecture 3, this is done in lecture 10, so this must be more advanced material. And we can figure out this kind of relationship, okay? All right, so then you do this whole thing for different courses, maybe one at Berkeley and maybe one at Columbia or MIT and Stanford. And what you really want to do is to use this technique in natural language processing called vector space models. And that's basically a way of representing a paragraph, if you will, in terms of a vector. A vector consists of the different terms. And you want to be able to do that. And whenever two of the courses, two pieces are very close in terms of similarities, similarity as measured by something called cosine similarity, then we can link them together to be able to do that, all right? So that's pretty much it. And later on, if somebody say, I don't understand DNA, then you can say, well, maybe you should look for something about the lectures about the prerequisite. If you say, I know this already, tell me more about other things, then you will figure out something else. So I don't know whether I'm going to be successful in playing this video. If not, I have to do that. This is a 1.5 minute video. Would it work? Huh? No sound?
Many courses available on the internet using different platforms such as Coursera and edX. If a student wants to learn something about language models, for example, he or she can type a search query.
Sorry, I'm going to start from the beginning.
The increasing popularity of massive open online courses, or MOOCs, has resulted in many courses available on the internet using different platforms such as Coursera and edX. If a student wants to learn something about language models, for example, he or she can type a search query into the lookup window and receive several course suggestions. However, there is no easy mechanism for the student to determine how the courses are related and which one to choose. The problem is even harder if one wants to search across multiple platforms. CUHK is a tool developed at MIT to help students taking MOOC courses to visualize the relationship among many courses from multiple online MOOC platforms. By linking these materials together and presenting them in an intuitive interface, CUHK can potentially help a student customize their learning environment by choosing the suitable learning path, reviewing background materials, or skipping ahead to more advanced topics. The linking is achieved using human language technologies. In this demonstration, after a student types language model into the lookup window, CUHK returns 2 related lectures from Coursera, one from Stanford and one from Columbia, each highlighted in a different color. The student can retrieve the material by clicking on the corresponding node.
Okay, so the first topic we're going to cover in this course is the problem of language modeling.
Through automatic linguistic analyses of the transcriptions of the lectures, the system can organize the lectures from these courses into a single map by linking the lectures on the same or similar topic marked in red. For this example, it is clear that the course materials for the two are quite similar for the first several lectures before they diverge. By clicking the red nodes, the student can compare the two courses on the same topic side by side. In the next example, the student is interested in learning about Python. CUHK returns 3 courses across 2 different platforms, edX and Coursera. The colored nodes show the various combinations of the 3 courses. The final example highlights CUHK's ability to help a student create a customized learning path. A student interested in learning about DNA can type DNA into the lookup window. CUHK then returns several related courses across multiple platforms. The system also links the input key terms with their prerequisite concepts, shown on the upper left. By clicking Inheritance, the material related to inheritance will be displayed for the student to review. By the same token, the student can skip over the current topic and explore more advanced topics suggested in the upper right. In this example, the student clicks RNA and the corresponding advanced material will be shown.
Okay, my time is almost up. So I would just say that we're working on a number of topics at Spoken Language Systems Group. We have already mentioned the automatic content linking. We also are doing some work in topic modeling, video processing, and also in sentiment analysis. So in summary, what I am trying to say here is that we have done some work in the area of applying human language technology to the problem of MOOC. And we have got some interesting results. Improvement, extensions, and all those kind of things are ongoing. And we're very interested in finding people, like-minded people to be working on this, and so that we can achieve impact. Thank you.
Thank you, Professor Xu. We will now have a Q&A section. May we invite Professor Helen Mang to host this section for us?
Very much for the marvelous talks. So we're actually running a little bit late, and so I suppose I should probably keep the Q&A session brief. But may I ask the audience, are there any questions with regards to any of the talks and materials that are presented this morning? Yes?
So I'd be quite interested in hearing about experiences with or knowledge about adapting computer-mediated learning to different personal cognitive styles and abilities and things, differences in memory ability, retention, the speed it takes to commit something to memory to the first time, visual processing, auditory processing, basically different abilities, cognitive abilities, yeah.
Okay, would any of our speakers care to share some views? I think, I mean, personally, I think being able to capture the data trace of the student learning in situ, I think that will reveal a lot of the abilities issues that you mentioned. I think we can track the process of learning and track understanding, as you could see in our last talk by Professor Zhu. I think it will be very revealing. Are there any other answers, comments? No? Other questions? Yes, Professor Leung Yi. At the back, yes.
Okay, I think one of the advantages of classroom learning is the instantaneous Q&A, right? So I just wonder whether this feature, how to accommodate this feature into e-learning, okay? Because students don't have the advantage of asking the question and then the teacher will be answering the question, okay? So I just wonder, with a class of 100,000 students, how can it be entertained, in e-learning?
Erwin, I think.
I'll say a few things, some technologies that could help. For example, there are some technologies using Q&A, question and answering system. So when you pose a question, we actually have a knowledge database that will find similar questions and the answer to that similar questions to you, right? So these are kind of template approach. Then on MOOC classes, in fact, there are TAs. They are standing by in the classroom hour or office hours that will respond to you. So I think there are ways that we could help to answer a particular type of questions. If it's some type of questions is like recurring question, that's FAQ, right? But sometimes you need to have a face-to-face. Then MOOC will provide video, face-to-face video link, one-to-one, one-to-many, many-to-many type of link to facilitate that type of things. So we are working on it, trust me. We're working on it. Have better engagement,
Great.
yes.
Yeah. Other questions? Yes, Gloria?
It's going to influence the people way of thinking. So how can I teach a primary kid to think like, use the programming mindset to think of that? Because for me, I'm an information engineering student, and I start learning programming when I was in year 1, and then it's very difficult for myself to adapt the program flow and then the logic thinking and so on and so forth. And so currently, I'm doing some program for the primary kids and the like junior secondary school student about programming course, and I'm struggling to how to teach them to think on the program, like the way of program, what program think. Yeah, how can I teach them?
That's a great question, and I apologize I don't have a great answer for it. But I have to say, I think the first step to teaching children to, computer thinking is to learn to do it ourselves. I think that we have to cross that threshold in order to be able to teach it. In general, it's hard for a teacher to teach something that they haven't internalized themselves. So I do think that's the first step. I think that there are lots of resources and lots of people who are thinking creatively about how to use computer-related thinking, even without using computers, in various topics, including a lot of topics that children can relate to. And you can learn a lot by exploring these sources. So I'm not particularly an expert in them, and I don't think any of us are. But this is something that is becoming quite popular, and I think that there's a lot of work out there, a lot of kindred spirits, and doing a little bit of research will give you a lot of clues about how to proceed.
Yes, last question, Jenny, Professor Jenny Lloyd.
This is really a blue skies request rather than a question. When I was a student, the advice I was given is don't pick the course by the content, pick the course taught by the great professors. So I'm thinking, how can, and part of that great professors is the energy that they generate in the classroom. So I'm thinking, what kind of technologies can we be thinking about that can transmit that energy on a massive scale across the MOOCs? Just as I guess food programs wants to transmit smells. So we want to transmit the energy that's taught by that great professor to the millions of people that will be taught. So I encourage all the scientists here to think about how we can develop technology to assist the transmission of that enthusiasm and inspiration to massive students.
That's another great comment. I don't think it's a question, but a comment. It occurs to me and lots of other people that with the as education moves online, and many of us think that this is just the beginning of a massive revolution, that education is going to be globalized. Professors are going to be sharing their curricular components globally over the internet with other professors in various other places. It's conceivable to me that in each domain there will be emerging a superstar who is the best at teaching that, and because of the global competition in this, this global shared curriculum, whoever is the superstar is going to emerge and dominate all of the others, and the others will sort of fall by the wayside. Now, that's a little bit unfair. I think that the great way of teaching, tensor calculus or whatever, is going to be contributed to by lots of people. People will contribute components. But the person who is actually the best at presenting them and lecturing may very well emerge as being the recognized expert. So maybe there'll be only one professor, superstar professor in each topic. Who knows? My colleagues may all disagree. But I'm not the keeper of the microphone.
So, last comment? Yeah, one more comment?
It's a comment relevant to this. You said great professors can generate energy. Now, there is another way to generate energy within the learners, and this is not the same way, but the idea of gamification has been applied to various domains. For example, language learning. I do not know how successful this can be in various domains, but I think that is one way of generating energy and enthusiasm within students.
Okay. So we have last request to...
Alright.
Oh, okay, one more. Okay.
Okay, I'd like to ask a general question. I think that when we look at online learning, I think one of the benefits is that we can connect the micro modules together into like connecting so that people trying to learn a topic, you can connect the micro modules to teach them on a particular topic. The difficulties that we are seeing now is that these micro modules, each one of them are like a small program or small programming module. And each one of them may have slightly different input-output specifications. And when you connect them together, from the outside, they may look similar. They may look identical, or they may look connectable. But when you actually put them together, they are not, because they make different assumptions, they have different terminologies. And therefore, when you view them together, they don't make sense. I mean, that is the difficulty, I think, in online learning. From the philosophy, the general philosophy may look good, but there are practical difficulties when you try to do that.
Mm-hmm.
In fact, the talk that I would have given today, if I hadn't been talked out of it by my colleague, Victor, is on precisely that topic. It's something I'm very interested in. And there's a process that I refer to as commoditization of courseware that I think we need to go through. We need, and we've been through it in many, many other domains. Those of us who are old enough remember when personal computers and dynamic RAMs and so on got commoditized so that different manufacturers were producing different versions that were all plug compatible. Okay? We haven't done that in our courseware. As you point out, there are lots of things that are precious nuggets that are taught at MIT, but they're so intricately tied to other things that are taught at MIT that they can't be very easily exported. Okay? My view is that the solution to that problem, and this is a typical, straightforward engineering technique that we use in many, many other domains, but not yet in education. The trick is to come up with specifications of each module that are sufficiently accurate that they allow the module to be, replaced by some other module that satisfies the same specifications. And a couple of us have been working on a system at MIT, a prototype of a system at MIT that does that kind of, provides that kind of specification. We sort of call it a curricular API. That allows, fine-grained modules to be produced by lots of different sources and, different people who produce modules that address the same set of curricular goals are in some sense competing with each other. But we're hoping to be able to enable a global competition so that the best way of teaching, each topic will kind of emerge by, people voting with their feet. So.
You can give this talk this afternoon.
Yes.
I could.
So, Erwin, you have one more? No? Okay, so with that, speaking of inspirational energy from rock star professors, I'm sure you agree with me that we had a very intensive morning of talks. But may I also reveal, actually, that our distinguished speakers from MIT, they were caught in this flight cancellation problem because of snow in Chicago, so their flights were canceled. And they had to reroute to Toronto. So in fact, they only, after a long haul flight, they only arrived in Hong Kong this morning at 5:30. So it's amazing, you still see so much energy from them delivering their wonderful talks this morning. And please join me in thanking them. I'd also like to thank Mr. Patrick Hoon, Mr. Ian Hoon, and Mr. K.T. Poon from the Sir Stanley Ho Medical Development Foundation for such a strong support that make this workshop possible. And finally, our student, our MC, Ms. Gloria Satine, and also our wonderful student helpers, please stand up and please join me to thank them too. Okay, so with that, I declare the completion of this workshop. We have learned a lot, and we know that we need to work very hard to leverage the potential of e-learning to make education better for ourselves and for our next generation. Thank you for coming.
Thank you, Professor Mang. This will be the end of the CHK MIT John workshop and e-learning and big data.